Hi guys, welcome to my channel. In this video, I will be covering complete unit 2 in computer network subject. I will explain all these topics in detail. Guys, whatever the topics that I am going to cover in this video, I will provide all those topics and the timings in description. So before starting this video, please check in description. I will explain what is data link layer and design issues of data link layer, similarities and differences between flow control and error control, what is framing, various types of framing methods in data link layer, what are error detection methods, that is VRC, LRC, checksum method and CRC, and what are error correction methods in data link layer. I will explain Hamming code method with example, and next I will explain what is point-to-point protocol, what is DSL, that is digital subscriber line, what is ADSL and HDSL, and I will explain what are elementary data link layer protocols. I will explain both noiseless and noisy protocols, and what is piggybacking, what is sliding window protocol, and types of sliding window protocols, that is 1-bit sliding window protocol, sliding window protocol using go backend, and sliding window protocol using selective repeat. And I will explain what is max sublayer protocol. I will explain random access protocols, controlled access protocols, and channelization protocols. I will explain all these protocols in detail. Next, I will explain what are collision free protocols and what is Bluetooth, Zigbee, what is bridge and types of bridges, what are wireless LANs, what is IEEE 802.11 standard. I will explain architecture, services, and as well as frame format of IEEE 802.11 standard. And also I will explain what is static channel allocation and dynamic channel allocation. I will explain all these topics in detail. Guys, I will provide complete unit to study material link in description. You can download from description. Guys, I have uploaded complete computer network subject tutorials. I will provide that link in description. You can watch from there. If you are watching this video for the first time, don't forget to like, share and subscribe to my channel. Let's get started. At first, I will explain what is data link layer, and I will explain functions and design issues of data link layer. Data link layer is the second layer of the OSI model. It is present above the physical layer and below the network layer. Guys, data link layer will perform 5 main functions. I will explain each of them in detail. First function performed by data link layer is framing. Guys, data link layer will not send our data directly to receiver. Instead, data link layer will divide our data into smaller packets, and then data link layer will place each packet in one frame, and data link layer will forward that frame to receiver. I'll give example. Guys, for example, I will send message how are you to my friend. Whenever I send how are you, my message is converted into smaller packets like how is one packet, R is one packet, and U is one packet. And then data link layer will place each packet in one frame, and then data link layer will forward each frame to receiver. Instead of sending our data directly to receiver, data link layer will pack our data in frame, and then data link layer will send that frame to receiver. So data link layer will perform framing, and second function is error detection and correction. Guys, data link layer can detect errors, and as well as data link layer can correct errors. Errors are classified into 3 types. They are single bit error, multi-bit error, and burst error. Yes, for example, I will send message hello to my friend. Whenever I send a message hello, that hello message is converted into binary format, that is zeros and ones. So hello is converted into 10111011. For example, single bit error means only one bit will be changed in message due to some noise. For example, due to some noise, this 1 is changed to 0. So whenever there is single bit change, receiver will receive wrong message. So instead of hello, due to single bit change, person will receive message like HELLI. In place of O, person will receive I due to single bit change. That's multi-bit error mean there will be multiple bit changes due to noise. For example, 1 is changed to 0, and as well as here 1 is changed to 0. Person will receive wrong message like JELLI due to multi-bit change. And whereas burst error mean complete bits are changed due to noise. For example, 1 is changed to 0, 0 is changed to 1, and 1 is changed to 0, and again 0, 1, 0. So there is complete bit change. So receiver will get wrong data like JIWO. And data link layer will handle these errors by using various kinds of methods. These methods are VRC, LRC, Checksum and CRC. If data link layer want to change error message into actual message, then data link layer can use error correction methods. One of the famous error correction method is Hamming code method. By using this method, data link layer can detect and as well as correct error. And the other function of data link layer is flow control. If sender send data too fast to receiver, then receiver cannot handle the data and receiver may drop some frames. So receiver cannot get actual data. So flow control means how much speed receiver can handle data. Only in that speed, sender must send data. And fourth function is MAC addressing. So along with our message, we will include sender MAC address and as well as receiver MAC address. As sender will send data correctly to receiver based on MAC address. Data link layer will use MAC addresses in order to identify device in network. Based on this MAC address, data will be transferred to receiver successfully. Another function of data link layer is acknowledgement of data. Thus, acknowledgement means replay message. Whenever sender send data to receiver, then receiver will give replay. Whether data is received successfully or not. That replay message is known as acknowledgement. Data link layer will provide three types of services. And the first one is unacknowledged connectionless service. Guess name itself says connectionless service. For example, there are two devices which are connected without cables. For example, they both will connect by using Bluetooth. Unacknowledged means sender will continuously send data and whereas receiver will not give any acknowledgement. That is nothing but receiver will not give replay whether data is received successfully or not. And next one is acknowledged connectionless service. Same example, but whenever sender send data, receiver will send acknowledgement. That is nothing but receiver will give replay like data is received successfully. And whereas in acknowledged connection oriented service, two devices will connect by using cables and whenever sender send data, receiver will send acknowledgement. Receiver will send replay like data is received successfully. These are three services provided by data link layer. Next I will explain design issues in data link layer. And the first one is framing issue. Guys, data link layer will divide our data into frames. Data link layer must divide our data into meaningful frames. If data link layer divide our data meaninglessly, receiver will not understand message. That is why data link layer need to frame our data meaningfully. Guys, in order to frame our data link layer will use various kinds of techniques like character count method, character stuffing method. By using these methods, data link layer can frame our data meaningfully. And second one is error control. Due to some noise or interference in network, receiver may receive wrong message. So in order to identify errors in our data link layer will use various kinds of techniques like CRC, LRC, Checksum and VRC. And data link layer can also correct that error. In order to correct error, data link layer will use technique like Hamming code method. Next design issue of data link layer is access control. Guys, for example, there are multiple computers which are connected to single cable. By using single cable, all devices will communicate to each other. For example, at a time, this computer and as well as this computer will send data to this computer. Whenever two computers send data at the same time to particular computer, then collision will occur. Collision is nothing but data loss. As two computers are sending data at the same time, both data will be lost. Receiver cannot receive data. In order to overcome this problem, data link layer will allow only single computer to send data at a time. Only after one computer sending data, other computer is allowed to send data. This is meaning of access control. So for access control, data link layer will use various kinds of protocols like CSMA CD protocol and CSMA CA protocol, which will avoid collisions. And next one is flow control. Flow control means how much speed receiver can receive data. Only in that speed, sender will send data. Data link layer will use stop and wait protocol and as well as sliding window protocol in order to handle flow control. And last issue is acknowledgement and retransmission issues. Thus, whenever sender send data, sometimes data will be lost and receiver cannot receive data. So if there is any data loss, sender will again send data by using ARQ protocols, where ARQ stands for Automatic Repeat Request Protocols. Next I will explain what is framing and various kinds of framing methods in data link layer. Data link layer will send our data from sender to receiver. Data link layer will not send our data directly to receiver. Instead, data link layer will place our data in frame and then complete frame is transferred to receiver. So framing is like packing. Instead of sending our data directly to receiver, data link layer will pack our data in frame and then complete frame is transferred to receiver. Frames will handle error control and as well as flow control. Data is successfully transferred to receiver without any errors. This is meaning of error control. And whereas flow control means how much speed receiver can handle, only in that speed sender will send data. This is meaning of flow control. So data link layer will handle error control and as well as flow control by using framing. Whenever we send data in a frame, we need to mark start point and as well as end point to our data in the frame, so that receiver will understand where our frame will start and where our frame is ended. Yes, for example, I want to send message, how are you to my friend. So whenever I send how are you, my complete data is not sent at a time to receiver. Instead, my data is divided into various parts. We call each part as packet. So how is one packet, R is one packet, and U is one packet. And each packet is placed in a frame and then complete frame is transferred to receiver. As there are three packets are placed in three frames and then transferred to receiver. If you observe here, I am not including any starting point and ending point of our data which is present in the frame. So whenever I send data without any starting point and as well as ending point, then our message will mix up and receiver will not understand our data. Receiver will receive data like this, which is not understandable to receiver. That is why we need to include starting point and as well as ending point of our data for each frame. Guys, we call start point and as well as end point as flags. So we need to include one flag, it's starting of our data, another flag, it end of our data. Okay, same example, but instead of sending data without any flags, data link layer will include flags at starting and as well as at the end of the frame. For example, let us say hash is considered as flag. So data link layer will include hash at starting and as well as at the end of the frame. So data will be forwarded like this, where this is one flag and this is other flag. We need to include flags for each and every frame. As we are including flags for each and every frame, now receiver can read data correctly. So whenever receiver receives each frame, receiver will decode that frame and then receiver will read the data. Decoding is nothing but whenever receiver receives each frame, receiver will remove flags and then receiver will read actual data. At first receiver will read how and then R and then U. If you want to mark starting point and as well as ending point to your frame, then there are various framing methods available. And the first one is character count method. In character count method, first byte of the frame tells how many bytes are present in the frame. At first, receiver reads this number and then receiver will extract correct amount of data. I'll give an example. Let's for example, whenever sender send hello message, then character count method will convert data like 5 hello, where 5 is nothing but count of these characters, as there are total 5 characters, HELLO. So whenever receiver receive data, at first receiver will read count and then based on count, receiver will read data. Let's for example, sender will send hello btech. So whenever sender send hello btech, character count method will convert data like 5 hello and as well as 5 btech. And whereas this 5 is nothing but count of these characters. And similarly, 5 is count of these characters. Hello, total 5 characters and as well as btech, total 5 characters. At first receiver reads 5 and receiver will understand that this frame contains 5 characters. So receiver reads 5 characters. Similarly, receiver reads other frame as there are total 5 characters. Receiver extracts other 5 characters. So receiver receives data like hello, btech. So in character count method, first byte of the frame tells how many characters are present inside the frame. And based on this number, receiver will extract and read data. This is all about character count method. Next I will explain what is character stuffing method. The stuffing is nothing but adding extra characters to our data in order to avoid confusion. As previous hash example which I explained. That is example of character stuffing method. So in character stuffing method, we'll use special characters in order to mark start and as well as end of the frame. This is example which I explained before, where hash is special character. We will mark special character at starting and as well as at the end of the frame. Whenever receiver receives each frame, receiver removes flags and the receiver will read actual data. Yes, for example, sender want to send message, that is hello hash btech. If you observe here, my flag is hash and as well as message also contains hash. So whenever message contains flag character, then character stuffing method will include backslash symbol hash, which is starting flag, and then hello and backslash hash. Whenever character stuffing method include backslash, receiver will understand that this hash belongs to message, not flag, and next btech and hash, where this hash is flag and this hash is flag. Whenever receiver receive data, receiver will remove backslash symbol and then receiver reads actual data. So receiver will read hello hash btech. This is all about character stuffing method. Stuffing is nothing but adding special characters at starting and at the end of the frame. That's not only hash, you can include any special character like %, $, etc. And if that particular character is present in message, then we need to include backslash symbol. That's it. And last method is bit stuffing. As previously character stuffing method, we will add special characters. And whereas in bit stuffing method, we will add bits as flags. Bits are nothing but zeros and ones. I'll give one example. As for example, sender want to send data like 100001. And whereas bit stuffing method will add some bits as flags. As for example, I'll take flag as 111. So bit stuffing method will add 111 and then actual message, that is 100001, and again at last 111, where this 111 and this 111 both are flags. And whenever receiver receive data, receiver will remove flags and then receiver will read actual message, that is 100001. As for example, sender want to send one more data like 101101. If you observe here, my flag character is 111 and as well as my message also contains 111. So whenever flag characters are present in our message, then receiver don't know what is flag and what is actual data. In order to overcome this problem, we need to avoid flag bits in our data. How can we avoid flag bits? Just we need to include 0, that is extra bit 0 after 2 ones. So bit stuffing method will have flag, that is 111, and then data, that is 10. Yes, actually here there are 111s. So what bit stuffing method will do is, bit stuffing method will add extra 0 after 2 ones in order to avoid flag in our data. So 11 and 01. Instead of 111, bit stuffing method will add extra 0 after 2 ones and then 01. Now there are no flag characters in this data and again add flag at last. So whenever receiver receive data, receiver will remove flags and as well as extra 0 and then receiver reads actual data, that is 101101. Guys, not only 111, you can take any bits, but that bits must not repeat in your data. This is all about bit stuffing method. Guys, instead of characters, if you are sending bits as data, then data link layer will use bit stuffing method. Next I will explain what are various error detection methods in data link layer. I will explain all these methods in detail. Before explaining various error detection methods, at first you need to know what is error detection. Error detection is the process of identifying errors in data transmission. For example, sender will send data like hello. For example, let us say hello binary code is 10111010. For example, whenever sender sends data, due to some noise and interference, this last bit 0 is converted to 1. As there is bit change, receiver may receive wrong data like HELLI. In place of O, receiver will receive data I, which is wrong message. So what are the bits that are changed due to noise in data transmission? We need to identify the bits. We call this process as error detection. As there is only single bit change, we call it as single bit error. Yes, for example, due to noise, so many bits are changed. For example, 1 is converted to 0 and again 0 and again this 1 is converted to 0, 1 and again this one 1 and 0, 1. If so many bits got changed due to noise, then we call it as burst error. So error detection is the process of identifying errors in data transmission. Error detection will make sure that receiver data is same as the sent data. And this error detection is done by using various techniques like VRC, LRC, Checksum method and CRC. Guys, before explaining various methods, at first you need to know what is redundancy. Guys, for example, our data is 10111011. This is our data. Along with our data, we'll add some extra bits. Like, for example, I will add 1011. Guys, we also call these extra bits as redundant bits. By using these extra bits, we can detect and as well as we can correct errors in data. So redundancy is nothing but adding extra bits to our data. These extra bits are used to detect and as well as correct errors. Guys, for example, sender want to transfer this data. Guys, sender computer contains generating function. Generating function is nothing but it is an algorithm. So whenever data is given to generating function algorithm, then automatically generating function will create extra bits based on our data. So actual data and as well as extra bits, both are combined and then sent to receiver. And whereas receiver computer contains checking function, it is also an algorithm. By using extra bits, checking function will identify whether data is received correctly or not. If data is received correctly, then checking function will accept data, or else checking function will reject data. Redundancy means extra bits added to our data. By using that extra bits, receiver will identify whether data is received correctly or not. Error detection methods are classified into 4 types, and the first one is vertical redundancy check. Shortly we call it as VRC. Guys, we also call VRC as parity check method. VRC method will identify errors by adding extra bit to our data. So VRC is a simple error detection method where an extra bit is added to our data. We call this extra bit as parity bit. I will explain VRC with an example. Just for example, sender want to transfer data, that is 11000001. If there are odd number of ones in our data, then VRC value is 1, and if there are even number of ones in our data, then VRC value is 0. If you observe this data, total there are 3 ones. So 3 ones, which is odd number. As there are odd number of ones in our data, VRC value, that is 1, is added to our data. We call this extra bit as parity bit. So in VRC, parity bit, that is 1 plus our data, that is 11000001. Both are combined and then transferred to receiver. This is sender data, and receiver will receive data like 1, which is parity bit, and 11000001. This is data which is received by receiver. Now based on this parity bit, receiver will identify whether data contains errors or not. As sender's data contains odd number of ones, and we are adding extra bit, that is 1, to our data, as receiver receives both parity bit and as well as actual data. Now here count will be even number of ones. Total there are 4 number of ones, 1, 2, 3, 4. If sender data contains odd number of ones, then receiver data must be even number of ones. If receiver receives data with even number of ones, then data is correct. Receiver got data without any errors. Just for example, actual data is 11000001, which is actual data. But due to some disturbance and noise, receiver received data like, in place of 0, receiver receives data like 1. So in place of 0, receiver got data 1, which is wrong data. Now receiver will count ones. Total there are 1, 2, 3, 4, 5. 5 ones. As sender data contain odd number of ones, and receiver's data also contain odd number of ones. As receiver got odd number of ones, receiver will know that data is wrong data. So VRC can detect single bit error. Guys, VRC method can detect only single bit error. If multiple bits are changed in data, then we call it as brushed error. VRC cannot detect brushed errors. Just for example, now multiple bits got changed. For example, sender data is 11000001. But here, in place of 1, receiver receives data 0. And similarly, in place of the 0, receiver receives data 1. Actually here, 2 bits got changed. This one and as well as this one. So even the 2 bits got changed. So whenever receiver receives data, receiver will count ones. As sender data contain odd number of ones, receiver count must be even number of ones. Now if you observe count 1, 2, 3, 4, which is even number. Though 2 bits got changed, receiver count is even number. So receiver will think that there are no errors in data, but actually 2 bits got changed. So VRC method cannot detect brushed errors. This is an algorithm for VRC. So in sender side, sender will count a number of ones in data. If number of ones is even number, then parity bit value is 0. If number of ones in our data is odd number, then parity bit value is 1. So actual data and as well as parity bit value, both are combined and then data will be transferred to receiver. Now receiver receives data and as well as parity bit. And even in receiver side, receiver will count a number of ones. As sender's data contain odd number of ones, so receiver count must be even number of ones. If there are even number of ones in receiver side, data is correct, else then data is wrong data. As in VRC method, in sender side there will be algorithm called even parity generator. Whenever data is given to this algorithm will automatically count the number of ones, and based on count, this even parity generator will generate parity bit, that is 0 or 1. Just for example, I will send the data, there are 2 ones, which is even number. So whenever data is given to even parity generator, as our data contain even number of ones, so parity bit 0 is added to our data. So our data and as well as parity value, that is 0, both are combined and then transferred to receiver. Thus here there are even number of ones. So whenever extra bit 0 is added to our data and even in receiver side, number of ones must be even number. So whenever parity bit 0 is added to data, both sender side and as well as receiver side, both side count must be even number of ones. For example, in place of 0, receiver will receive data 1. Now receiver will count number of ones. Total there are 3 number of ones, which is the odd number. Now receiver will understand that data contains errors. So whenever parity bit 0 is added to data, both receiver side and as well as sender side, both count must be even number of ones. Next I will explain what is LRC, where LRC stands for Longitudinal Redundancy Check. Guys, if we consider VRC cannot detect brushed errors. Brushed errors mean if multiple bits got changed in data, VRC cannot detect brushed errors. And whereas if we consider LRC can detect brushed errors. Guys, in LRC, we will arrange data in the form of rows and columns. I will explain LRC with an example. Guys, for example, there are multiple blocks of data like 1110011 and similarly 1101101 and 001111001 and 1010101. These are various data blocks which sender want to send to receiver. Whenever sender want to transfer data to receiver, along with our data blocks, sender will add some extra bits to our data. We call that extra bits as LRC. So sender will send data and as well as LRC that are nothing but extra bits. Based on this LRC, receiver will identify whether data contains errors or not. And whereas in LRC, at first we will arrange data in the form of rows and columns. These are data blocks. Total there are 4 blocks of data. So 1, 2, 3 and 4 blocks. So first block contain values 1, 1, 1, 00 and 111. And similarly second block contains 1, 1, 0, 111, 01. And third block contains 00, 111, 001. And fourth block contains data, that is 10, 10, 1001. These are our data blocks. Now we arranged our data in the form of rows and columns. Now we need to add LRC to our data. The same formula which we applied in VRC. If there are odd number of ones in our data, then LRC value is 1. And if there are even number of ones in our data, then LRC value is 0. And we need to calculate it column wise. So first column contains 1, 2, 3, 4. 4 ones, which is even number. So we need to add 0. And next column contains 1, 0, 0. As there is only 1, which is odd number. So we'll add 1. And next here 1, 1, 0, 0. 2 ones. 2 is even number. If there are even number of ones, we'll add 0. And similarly here 3 ones, which is odd number. We'll add 1. 2 ones even, we'll add 0. And here 3 ones, which is odd number. So we'll add 1. And next here 2 ones. So we'll add 0. And again here 3 ones, which is odd number. So we'll add 1. So now we got LRC value. Now both LRC value and as well as data, both are combined and then transferred to receiver. This is LRC value plus data. Both are combined and then transferred to receiver. So whenever receiver get this data, receiver will separate LRC and then receiver will again calculate LRC. Yes, same way. How sender calculated LRC, in same way receiver will calculate LRC. After calculating LRC, if sender's LRC and as well as receiver's LRC, if both values are equal, then receiver got correct data or else receiver got wrong data. That means receiver data contains errors. This is all about LRC. Yes, for example, first block contains data like 111, 00, 111. But whereas in receiver side, at last, here in place of 1, receiver will receive data 0. So your last bit is 0. And similarly, in second block first bit, in place of 1, receiver will receive 0. So in second block first bit, receiver got 0 in place of 1. Now in receiver side, receiver will calculate LRC. Previously data contained 4 ones, which is even number. But as 1 is changed to 0, now data contain odd number of ones. So we'll include 1. And previously here, there are odd number of ones. But here data got error. That is 1 is changed to 0. If you observe count, there are even number of ones. So 1 is changed to 0. and whereas sender data is 10, 10, 10, 10. But whereas receiver data is 00, 10, 10, 11. So receiver will identify that data contains errors. As sender's LRC is not equal to receiver's LRC, now receiver will know that data block contains errors. As if you observe here, multiple bits got changed. That is nothing but data contains brushed errors. So if there are brushed errors in data, LRC can identify that errors. Yes, there is one problem with LRC. That is, LRC will not detect errors if 2 bits are changed in same column. I will explain with an example. Yes, for example, if you consider this column, here there are 2 ones. As there are 2 ones, which is even number, so extra bit added is 0. But due to some noise in data transmission, the 0 is changed to 1 and 1 is changed to 0. So if you observe here, 2 bits got changed in same column. Now if you count, total there are 2 ones, which is even number, so still value is 0. Even though data got error, still our value is 0. So whenever receiver receives data, receiver will think that there are no errors in data, but actually data contains multiple errors. So LRC cannot detect errors if 2 bits got changed in same column. In LRC, our block of bits are organized in rows and columns. So we can also call LRC as 2-dimensional parity. As LRC is old network protocol. Now LRC is replaced with CRC, where CRC stands for Cyclic Redundancy Check. Next I will explain what is checksum method. Thus by using checksum method, we can identify errors in transmitted data. Yes, for example, our complete data is divided into various blocks. After dividing our data into various blocks, we need to perform binary addition between these blocks. After performing binary addition between these blocks, we will get one result. We call this result as checksum. So data and as well as checksum, both are combined and then transferred to receiver. Based on checksum, receiver will identify whether data contains errors or not. I will explain with an example. This is how checksum will work. And the first step is, we need to divide our data into fixed size blocks. I am selecting size 4. Each block will contain 4 bits. This is block 1, block 2 and block 3. After dividing our data into fixed size blocks, next step is, we need to sum up all the blocks. That is nothing but, we need to perform binary addition between these blocks. Guys, I will explain what is binary addition. In binary addition, 0 plus 0 means 0, 0 plus 1 means 1, and 1 plus 0 means 1, and 1 plus 1 means 0, and where 1 is carry. I will explain what is carry. And whereas 1 plus 1 means 1, which is sum and which is carry. This is binary addition table. Guys, by using this table, now we need to perform binary addition between these blocks. So first block contain 0, 1, 0, 1, and second block contain 1, 0, 1, 0, and third block contain 1, 1, 0, 0. 1 plus 0 plus 0, as there is only single 1, 1 plus 0 plus 0 is 1. And similarly here, as there is only single 1, 0 plus 1 plus 1 is 1. And similarly here, 1 plus 0 plus 1. If you observe here, there are 2 ones. If there are 2 ones, then sum is 0 and carry is 1. So 1 plus 0 plus 1 is nothing but 0, 1 is carry. And similarly again, 1 plus 0 plus 1 plus 1. Total there are 3 ones. If there are 3 ones, then sum is 1 and carry is 1. So sum is 1 and carry is also 1. Guys, each block contains only 4 bits. So our checksum also must be 4 bits. But if you observe this result, checksum contains 5 values, which is wrong. So we need to remove this one and we need to add this one here. So again we need to perform binary addition, that is 1 plus 1. So 1 plus 1 means 0 and where 1 is carry. And again 1 plus 1, that is 0, 1 is carry. And again 1 plus 0, as there is only single 1, result is 1 and at last 1. Now there are only 4 bits. This is how we perform binary addition. After summing up all the blocks, third step is, we need to perform 1's complement of the sum. This is our sum. Now we need to perform 1's complement. 1's complement means zeros will become 1 and 1's will become 0. So 1 will become 0, 1 will become 0 and 0 will become 1 and 0 will become 1. This is known as 1's complement. After performing 1's complement, final result which we call it as checksum. This is our data. So data and as well as checksum, both are combined and then transferred to receiver. Whenever receiver receives data, again receiver will perform binary addition including this checksum. So our data is 0101, 1010, next 1100, and as well as checksum, that is 0 0 1 1. Yes, after performing binary addition, if result contain all ones, then there is no error. But if result contain any 0 bits, then our data contains error. Now we will perform binary addition. 1 plus 0 plus 0 plus 1. So 1 plus 1 is nothing but 0, and where 1 is carry. So 0 and this 1 is carry. Now again 1 plus 0 plus 1 plus 0 plus 1. As there are 3 ones, so 1 plus 1 plus 1 is nothing but 1 1, where 1 is sum and next one is carry. Again if you observe here 3 ones. 3 ones mean 1 is sum and next one is carry. And again if you observe here 1 plus 0 plus 1 plus 1 plus 0. Total there are 3 ones. So 1 plus 1 plus 1 is nothing but 1 and 1 is carry. Guys, here also we got 5 bits. But as our result contains 4 bits, this sum also must contain 4 bits. So we need to remove this one and we need to add here. Again we need to perform binary addition. So 0 plus 1, that is 1 and no value is 1, and again 1 1 1. My result contains all ones. So there is no error in our data. Yes, for example, receiver got error, like here in place of value 1, receiver got 0, as receiver got wrong data. Now again we will perform binary addition in order to check errors. So first value is 0 1 0 1, and next value contain 1 0 1 0, and third block contain 1 0 0 0, and fourth block contains 0 0 1 1. Guys, there are 2 ones. So 1 plus 1 is nothing but 0 and 1 is carry. And if you observe here, there are 3 ones. So 1 is sum and next one is carry. And similarly again 1 plus 1 plus 0 plus 0 plus 0. So 1 plus 1 is nothing but 0, which is sum, and next one is carry. And 1 plus 1 plus 1. Total there are 3 ones. So 1 is sum and 1 is carry. As there are 5 bits, remove this one and add this one here. So 0 plus 1 1 and 0 1. We got result as 0. Whenever sum is 0, then receiver will understand that data contains errors. Only if all values are ones, then there are no errors in data. If any of the bit contains 0, then receiver will understand that data contains errors. Whenever sender send data plus checksum to receiver, then receiver will add all the blocks and as well as checksum. If sum contain all the ones, then there is no error. Otherwise, data contains errors. This is an algorithm which shows how checksum will work. Next I will explain what is CRC. Guys, CRC stands for Cyclic Redundancy Check. I will explain CRC with an example. Yes, for example, sender want to send data, that is 100 100, and in CRC method there is divisor. This divisor is known to both sender and as well as receiver. So this value is known to both sender and as well as receiver. Based on this divisor, sender will calculate CRC value. Guys, CRC is nothing but CRC is extra bits added to our data. By using these extra bits, receiver will identify whether data contains errors or not. Guys, we will calculate CRC based on XOR table. For XOR operation, if both values are same, then result is 0, else result is 1. So for 0 0, result is 0, and for 1 1, result is 0. And for 0 1, result is 1, and for 1 0, result is 1. Based on this table, now we need to calculate CRC. Because divisor is 1101 and our data is 100 100. If our divisor contains 4 bits, then we need to add 3 zeros to our data. So we need to add extra 3 zeros to our data. If divisor contains 5 bits, then we need to add 4 zeros to our data. For example, if divisor contains 6 bits, then we need to add 5 zeros to our data. As divisor contains 4 bits, I am adding 3 zeros to my data. So first time we will apply XOR operation. First time I will divide. So 1101, and for these values we need to apply XOR operation. For XOR operation, if both values are same, result is 0. So for 1 1, result is 0, and for 0 0, result is 0, and for 0 1, result is 1, and again for 1 1, result is 0. Guys, 0 1 0 0, as the last value is 0, so need not to consider it. We can remove the 0. We need 4 bits, as there are only 3 bits. Now I will add the 0. Now there are 4 values. Again we need to divide. So 1 1 0 1. Again we need to apply XOR operation. So for 0 1 1, for 0 0 0, for 0 1 1 0. So 0 1 0 1. As the last value is 0, you can remove it and you can bring this 0. So 1 0 1 0. Again we will divide 1 1 0 1. So 0 1 1, 1 0 1, 0 1 1. and 1 1 0. As last value is 0, you can remove this and you can add this 0. So now there are 4 bits. Again divide. So 1 1 0 1. So 0 1 1 1 0 1 for 1 1 0 and for 1 1 0. As last two values are zeros, you can remove these 2 and you can add these 2 zeros. So 1 1 0 0. Again divide, that is 1 1 0 1. So for 0 1 1, for 0 0 0, for 1 1 0 and again for 1 1 0. Guys, divisor contains 4 bits. So we added 3 zeros. So even for CRC, we need to consider last 3 bits. So 001 is my CRC code. Now our data and as well as CRC code, both are combined and then transferred to receiver. So now both data and as well as CRC code, both are combined and then transferred to receiver. Guys, I already said before, this divisor is known to both sender and as well as receiver, and again receiver will perform XOR operation by using this divisor. So receiver performs XOR operation for this complete data including CRC code. Now we will apply CRC for this entire code. So 100 100 and 001, and our divisor is 1101. So one time we will apply divisor, that is 1101. If both values are same, result is 0. So for 110, for 000, for 011 and for 110, as last bit contains 0, you can remove this and you can add this 0. Again apply divisor 1101 for 011, for 000, for 011 and for 110. As last value is 0, so remove this and add this 0. 1010, again apply 1101. So for 011, for 101, for 011, for 110. As last value is 0, no need to consider this, remove this and add this 0. And again apply 1101. So for 011, for 101, for 110 and for 110. As last two values are zeros, you can remove this and you can add these two values, that is 0 and 1. So 0 and 1 and again apply 1101. Both values are same, in result is 0. So 0 0 for 110 and for 110. As all values are zeros, then receiver will understand that data received is correct data. The sender data is 100 100 and receiver also got data, that is 100 100. So data is correct data, that is why we got all bits as zeros. Just for example, in place of 100 100, if receiver receive data like 100 101, in place of 0 if receiver receive 1, whenever receiver perform the same XOR operation, then receiver will receive 1 bit as 1. So whenever receiver receive bit 1 in data, receiver will understand that data is wrong data. So receiver got data, that is 100 101. In place of 0, receiver got 1 and our CRC code is 001. So 1101. So one time I am applying 1101. So both values are same, 0 0 for 011, for 110. Remove the 0 and add the 0 and again 1101. So for 011, for 000, for 011 and for 110. Again last value is 0, so remove this and add this one, 1101. So both values are same, 0 1 1 0. Again remove the 0 and add this 0. So 1100, again 1101. So 1 0 0 0. So remove this value and add these two values, 0 1. So 0 1 0 1 and again apply 1 1 0 1. So for 110, for 000, for 110, and if you observe here, for 0 1 1. Only if receiver receives all zeros, then data is correct. Else if receiver receives any bit as 1, then data is wrong data. As in place of 0, receiver got 1. So here we got result as 1, which is wrong data. So by seeing this result, receiver will understand that he got wrong data. Next I will explain what are error correction methods in data link layer. Error control mean whenever sender send data to receiver, due to some noise or interference in network, receiver may receive error in the data. For example, sender will send data to receiver like hello. For example, hello binary code is 10111011. But due to some noise or interference in network, last bit 1 is changed to 0. So receiver may receive data like JELLO. In place of H, receiver will receive data like JELLO, which is wrong message. Now data link layer will identify this error, and as well as data link layer will correct this error by using various error control methods. Error control is the process of finding and fixing errors in the data transmission so that receiver gets the correct data. It ensures that if any error caused by noise or interference in the network are corrected. Guys, error correction methods are mainly classified into three types. And the first one is retransmission method. We also call this retransmission method as ARQ method, where ARQ stands for automatic repeat request method. Whenever receiver receives error in the data, receiver will correct that error just by saying sender to retransmit that same data again. So receiver will ask sender to send that same data again. This is how receiver corrects error in the data. ARQ methods are classified into two types. And the first one is discrete ARQ and second one is continuous ARQ. At first I will explain what is discrete ARQ. Whenever sender sends data to receiver, receiver will give reply whether data is received correctly or not. We call this reply message as acknowledgement. If data is received correctly, then receiver will give positive ACK, and whenever receiver receives error in the data, then receiver will give negative acknowledgement for sender. If sender receives negative acknowledgement, then sender will send that same data again. So in discrete ARQ, receiver will give reply to sender, that is positive reply or negative reply. We call that reply as acknowledgement, that is ACK. If sender receives negative ACK, then sender will again send that same data again. And next one is continuous ARQ. Whereas in continuous ARQ, complete data is divided into parts and then each part is transferred to receiver. For example, let us say sender will send data like hello, how are you? Hello is one part, how is one part, R is one part, and U is one part. So in continuous ARQ, complete data is divided into various parts and all these parts are continuously transferred to receiver. That is why we call this method as continuous ARQ. If receiver receives data with error, then receiver will again ask sender to send only that error occurred part. For example, receiver receives data like hello, how are you? But if you observe U, in place of YOU, receiver will receive data like YAU. As only this part got error, then receiver will ask sender only to send that error occurred part. So sender will again send that U. After receiver receiving error occurred part, then receiver will reconstruct that message like hello, how are you? And then receiver reads this message. This is all about continuous ARQ. So first error correction method is retransmission method. We also call it as automatic repeat request method, that is ARQ method. And whereas second one is symbol substitution method. Name itself says symbol substitution. Whenever receiver receives any characters with error, this symbol substitution method will include some special symbols like question mark symbol if any characters are corrupted. And there will be human operator who will identify these question marks, and then this human operator will correct errors manually. This method uses manual correction to fix errors. If a character is corrupted, it replaces with a special symbol like question mark. A human operator checks and corrects data manually. This method is used in older telegraph systems. This method is not commonly used today. And whereas third method is forward error correction method. Yes, whereas in forward error correction method, along with our data, we will add extra bits. And by using that extra bits, we can check error in the data. For example, let's say I'll send hello. Binary bits of hello is 1011. For example, along with my data, forward error correction method will add some extra bits like 110. These extra bits are used to check and as well as correct errors in the data. Guys, we'll use forward error correction in satellites and as well as in wireless networks. One of the famous forward error correction method is Hamming code method. Guys, I will explain Hamming code method with example. Next, I will explain what is Hamming code method. Guys, whenever one computer sends data to other computer, this Hamming code method is used to detect and as well as correct error in the data. Errors can happen due to noise. Whenever error occurs, bit 0 is changed to 1 and as well as 1 is changed to 0. This Hamming code method was invented by Richard Hamming. That is why they give a name Hamming code. By using this Hamming code method, data will be transferred from one computer to other computer without any errors. I will explain one simple problem by using Hamming code. There is 7-bit code and data is 1101. Add parity bits. Guys, in question they given, total there are 7 bits. Out of 7 bits, 4 data bits are given. 4 data bits are 1101. And we need to find parity bits. As we know, out of 7, 4 are data bits and remaining 3 are parity bits. Now we need to find what are parity bits. Guess Hamming code contains both data bits and as well as parity bits. Parity bits are nothing but parity bits are the extra bits added to our data. These parity bits are used to detect and as well as correct errors in the data. Total 7 bits starting from bit 1 to bit 7. At first we need to identify in which positions we need to place 3 parity bits. For that you need to remember formula, that is 2 power n, where n equal to 0, 1, 2, 3, so on. Just you need to remember formula, that is 2 power n, in order to identify positions of parity bits. So n equal to 0, 1, 2, 3, so on. So at first I will take 2 power 0. 2 power 0 is nothing but 1. So in first position we can place parity bit. So first parity bit is in position 1. Next n value is 1. So now 2 power 1. 2 power 1 is nothing but 2. So second position is available. So in second position we can place parity bit. And next 2 square, that is 2 into 2, that equal to 4. So fourth position is available. So in fourth position we can place parity bit. And next 2 cube, that is 2 into 2 into 2. 2 to the 4, 4 to the 8. But if you observe here, 8th position is not available. As there are total 7 bits, only there are 7 positions. As we need to find 3 parity bits, we got position of 3 parity bits. They are P1, P2 and P4. So we can place parity bits in position 1, 2 and 4. We got positions of parity bits. Now we will place our data bits in remaining positions. That is, we need to place data bits 1101. So 1101. So in remaining positions, we can fill data bits. Now what are the bits we need to place in these positions? We need to identify that. At first we will find parity bit in position 1. Just remember formula. P1 mean take 1 and skip 1. As position will start from 1, we will take position 1 and we will skip 1. That is, we will skip 2 and again take 3 and skip 4 and similarly take 5 and skip 6 and take 7. And no other bits are available, so you can leave. So P1 mean take 1, skip 1 and start from 1. So we are starting from 1, take 1, skip 2, take 3, skip 4, take 5, skip 6 and take 7. So positions are P1, 3, 5, 7. That there is no value in P1, so leave it. And whereas in position 3, value is 1, and whereas in position 5, value is 0, and whereas in position 7, value is 1. So now values are 101. If you observe here, there are 2 ones, which is even number. So if there are even ones, then parity bit is 0, and if there are odd number of ones, then parity is 1. As there are 2 even ones, then our parity will be 0. So parity bit 1, value is 0. So now we got parity bit value, that is 0. Next we will find P2 value. So P2 mean take 2, skip 2 and start from 2. So we need to start from 2, take 2 values, that is 2, 3, skip 2 values. So we'll skip 4, 5 and again we'll take 6, 7. After 7 there are no values, we can stop. So now we got positions of P2, that is 2, 3, 6, 7. As there is no value in P2 position, so you can leave. And position 3 contains value, that is 1. And similarly, position 6 contains value 1 and position 7 contains value 1. So value of P2 is 111. Guys, total there are 3 ones, which is odd number. If there are odd number of ones, then parity value is 1. So now P2 value is 1 because there are odd number of ones. Now we will find P4 value. Guys, P4 mean take 4, skip 4 and start from 4. So starting from 4, we'll take 4 values. So P4 is equal to 4, 5, 6, 7 and there are no values available to skip, you can leave. So P4 no value is available, you can leave, and P5 value is 0, P6 value is 1 and P7 value is 1. So now P4 values are 0, 1, 1. As there are even number of ones, so parity value is 0. So P4 value is 0. Yes, now we got 3 parity bits. They are 0, 1, 0. So along with our data, we need to add parity bits to our data. By using these parity bits, Hamming code method will identify and correct errors. So parity bits are P1, P2 and P4, and whereas data bits are D3, D5, D6, D7. This is how Hamming code method will find parity bits when data bits are given. This is one more example. A 7-bit Hamming code is received as 1011 011. Assume even parity and state whether received code is correct or not. Guys, we got this code, that is 10111011. This is 7-bit data which receiver got. Now we need to identify whether this code contains errors or not. At first we need to find parity bits. So in order to find positions of parity bits, formula is 2 power n, where n equal to 0, 1, 2, 3, so on. So first we will take 2 power 0. 2 power 0 is 1. So parity bit position is 1. And next 2 power 1. So parity bit position is 2. And next 2 square, that is 2 into 2, that equal to 4. So parity bit position is 4. And next 2 cube, that is 2 into 2 into 2, that is 8. 8 position is not available, so we can ignore. So now we got positions of parity bits. They are P1, P2 and P4. Guys, in question they given even parity. Even parity is nothing but all parity bits must contain even number of ones. If there are any odd number of ones in parity bits, then our data contains errors. At first we will find value of position 1. As P1 mean take 1, skip 1 and start from 1. So I'll take 1, skip 2, take 3, skip 4 and take 5, skip 6 and take 7. So P1 value is 1, P3 value is 0, position 5 contains value 1 and position 7 contains value 1. If you observe here, 1, 2, 3, odd number of ones. So we got errored data. And similarly we will find P2. P2 mean take 2, skip 2 and start from 2. So starting from 2, we'll take 2 values, that is 2, 3 and we'll skip 4, 5 and take 6, 7. So position 2 value is 1, position 3 value is 0 and whereas in position 6 value is 0 and whereas in position 7 value is 1. So 1, 0, 0, 1. As there are even number of ones, so there is no error in P2 position. And next one is P4. P4 mean take 4, skip 4 and start from 4. So starting from 4 we'll take 4 values. They are position 4, 5, 6, 7 and there are no other values. We can stop here. So P4 value is 1, P5 value is 1, P6 is 0 and P7 is 1. As there are odd number of ones, so parity 4 contains errored data. Guys, in question they given even parity. Even parity is nothing but all parity bits must contain even number of ones. If there are any odd number of ones in parity bits, then our data contains errors. Thus, if there are odd number of ones, parity value is 1 and if there are even ones, parity value is 0. So P1 value is 1, P2 value is 0 and whereas P4 contain odd number of ones. So P4 value is 1. So now we will identify in which position we got error. So total parity values are 1, 0, 1, base 2. So 2 power 0, 2 power 1 and 2 square. 2 power 0 is 1, 1 into 1 that is 1 and 2 power 1 is 2 into 0. So value is 0 plus 2 square that is 4. 4 into 1, 4. So 4 plus 0 plus 1 that equal to 5. So in position 5, data bit contain error. So in position 5, we need to change 1 to 0. This is how Hamming code will find errors in data. Next I will explain what is point-to-point protocol. Point-to-point protocol is a method used to connect two computers or devices directly so they can exchange data. It is like a private conversation between two devices. A computer connects to the other computer using a cable or a computer connects to the internet through a telephone line. Point-to-point protocol makes sure the connection is proper, secure and error-free. By using point-to-point protocol, we can connect only two devices in order to exchange data. For example, I want to send some files to my friend computer. So I will connect my computer with my friend computer directly by using cable. And then I will transfer files to my friend computer. As only two computers are communicating directly by using cable, this connection is private connection because no one is involved. So by using point-to-point protocol, two devices can communicate each other properly, securely and as well as error-free. There will not be any errors in data transfer. Next I will explain connection phases of point-to-point protocol. Guys, there are total 6 phases in point-to-point protocol. I will explain each of them. And the first phase is dead phase. In dead phase, nothing is happening. No data is being sent and the devices are not connected. The connection link is inactive. Guys, in dead phase, there are two computers. But these computers are not connected to each other and they are not transferring data. As there is no communication link between these two devices, communication link is inactive. This is dead phase. And second phase is established phase. One device wants to start a connection, so it activates the link it sends a request to other device using LCP, that is link control protocol. If both agree, the connection moves forward. Thus, for example, this computer wants to send data to this computer. This computer will connect to this computer by using cable directly. Before this computer sending data to this computer, at first this computer will send request. So if this computer accept request, then they both can communicate each other, like they can transfer data. And this computer will send request to this computer by using link control protocol. And third one is authentication phase. Sometimes the device may need to verify each other's identity. They do this using passwords. If authentication is successful, the connection continues. If authentication fails, the connection is terminated. This computer wants to send data to this computer. Before that, they will verify each other. Like this computer will enter password like 123, and same this computer also enter password 123. If both passwords match, then connection is successful. They both can communicate each other. For example, this computer will enter 123 and this computer will enter 456. As there is no password match, connection will be terminated. They cannot communicate each other. And fourth phase is network phase. In network phase, devices need to decide what kind of data they will send. Since PPP support different types of data, they also need to decide which protocol they will use, like IP or IPv6. Thus, normally we will send different types of data, like images, PDF files, songs, videos, etc. So in network phase, devices need to decide what kind of data they will send. By using point-to-point protocol, we can send different types of data. And in network phase, they also need to decide which protocol they will use, like either they will use IP or IPv6. And systems will decide all this by using network control protocol. This is all about network phase. And fifth phase is open phase. In open phase, device will start sending and receiving actual data. Guys, how much time devices communicate each other, that much time communication link is active. Communication link is nothing but wire. Guys, data is successfully reached to this computer. Now devices want to end communication. So if devices want to end communication, they need to move to terminate phase. When one device decides to end the connection, it sends a termination request. Guys, for example, this computer will send request to this computer in order to close connection. And acknowledgement is nothing but acceptance. This computer will accept termination request of this computer. So now connection is removed and both computers cannot communicate each other. Once connection is removed, device will go to first phase, that is dead phase. Guys, these are connection phases. We also call them as transaction phases. So dead phase, no connection is established, and in establishment phase, connection will be established between two computers. Guys, authentication phase is not mandatory phase. If devices want to verify each other, they will send passwords, and some other device will communicate each other directly without any passwords. If devices don't want to verify each other, directly they will go to network phase, and if devices want to verify each other, they will go to authentication phase. In authentication phase, they will verify password. If there is password match, so authentication is successful, they will go to network stage. And if authentication fails, computers cannot communicate each other, so directly they will move to terminate phase. And in network phase, computer will decide which data they want to send, either photos or PDF files or movies or etc. And they will also decide protocols, whether IPv6 or IP protocol. After network phase, device will move to open phase. In open phase, device can communicate each other by sending and receiving actual data. Once data transfer is successful, connection will be removed. In termination phase, one computer will send request to other computer in order to remove connection. If other computer accepts that request, then connection will be removed. And if connection is removed, then device will go to dead phase, as they are not connected to each other. These are various connection phases in point-to-point protocol. Next I will explain point-to-point protocol frame format. Guys, frame is like parcel. For example, I purchased one product in Amazon. So what they will do is, they will place that product in parcel and they will give me. Similarly, if one computer wants to send data to other computer, it will not send the data directly. Instead, this computer will place the data in frame and then it will transfer data. So frame is like parcel. Point-to-point protocol uses a frame format to ensure proper communication between two devices. Each frame contains different fields and each field has specific purpose. The structure of the point-to-point protocol frame is given below. Thus, point-to-point protocol frame contains various fields and each field will perform certain tasks. Thus, for example, I want to send hello message to my friend by using point-to-point protocol. So this hello message is considered as payload. So payload is nothing but actual data which I want to send. And it's starting, and at the end we will place flag. I will explain what is flag. As flag size is 8 bits, like 1, 2, 3, 4, 5, 6, 7, 8. Like that, flag size is 8 bits. We also call 8 bits as 1 byte. So in place of writing here 8 bits, you can also write here 1 byte. So flag size is 1 byte. Flag is marked at the starting and ending of the frame. This flag will indicate beginning of the frame and end of the frame. And flag value is always 0, 6 ones and 0. This is default value. This value will not change. If any device want to send data, by default, this is flag value. And this flag value is used to identify starting and ending of the frame. So by seeing this flag, receiver device can identify starting and ending of the frame. And second field is address field. This is also 8 bits. Just for example, this computer want to send data to this computer. So what this computer will do is, in this frame, this computer will include address of this computer. And default value is all ones. So 8 bits, total 8 ones. Guys, 8 bits are nothing but broadcast address. That is nothing but, by default, whenever this computer include all ones, that means data is transferred to all computers connected to this network. Though data is sent to all computers, only particular receiver will receive the data. So only this computer will receive the data. This is meaning of broadcast address. So by using address field, sender will identify receiver device and its value is always ones. And all ones are broadcast address. That means data is sent to all devices connected to network. And third field is control field. And here also there is default value, that is 00000011. This is default value. This control will define frame type. It specifies how the frame should be handled. It decides whether the frame need acknowledgement or not. It tells the receiver what kind of message it is. It treats all frame in the same way. Guys, whatever data we send by using point-to-point protocol, this control will treat all messages in same way. That is why we will include 6 zeros and double ones, total 8 bits. So for each and every message, control is same. Guys, for some important messages, receiver should replay. And for some other messages, there is no need of replay. So this control will decide whether receiver must send acknowledgement or not. Acknowledgement means replay. And fourth field is protocol. The protocol field in PPP frame tells the receiver what type of data is in the frame. Guys, normally we will send two types of data. One is IP packet. IP packet is nothing but any message that is sent by using internet is known as IP packet. For example, I will send a message hello to my friend. So this hello message is considered as IP packet. So normally we will send two types of data. One is normal IP data and next one is login verification. Whenever we enter username and password and click on login button, receiver must immediately give response, like whether user is correct user or not. So protocol field verifies whether data is internet data or login data. If data is internet data, then it will include value like 0x0021. For example, if this data is login data, then protocol field contain value, that is 0xC023. So based on these values, receiver will identify what type of data is present inside the frame. Whether data is IP data or login verification data. And protocol value is not 1 byte, it is 2 byte, that is 16 bits. And fifth one is payload. Actual data that is present inside the frame. We call this actual data as payload. And size can be up to 0 to 1500 bytes. Normally point-to-point protocol will carry two types of data. One is IP packet, that is nothing but internet messages. And next one is login verification data, in order to verify users. And sixth one is checksum. Yes, for example, I will send message hello, but receiver will receive data like JELLO. In place of H, he will receive data JELLO. So by using checksum method, we can identify errors. And checksum size is 2 bytes or 4 bytes. Next I will explain what is DSL, that is Digital Subscriber Line. Digital Subscriber Line is a high-speed internet technology that uses telephone lines to provide internet access without interrupting voice calls. It allows users to access the internet while making phone calls on the same line. Yes, normally if you consider Airtel Jio, but actually in olden days, they are only telephone lines. We can only do phone calls by using Airtel and Jio. But at present, by using Airtel, we can do phone calls and as well as we can access internet. So this Airtel and Jio, both are examples of digital subscriber line, where we can do both voice calls and as well as internet access. They will use single cable. So this single cable will provide both voice calls and as well as internet. As we are accessing voice calls and internet in only one single line, even though there will not be any interruption. So DSL will allow users to access internet and as well as phone calls on same line, that is by using single cable. Digital subscriber lines are classified into two types. They are asymmetric DSL and symmetric DSL. Guys, whatever the internet we are using in our house, that internet is ADSL, that is asymmetric digital subscriber line. As for example, by using my Airtel internet, I want to download movie. So simply within 10 minutes, I can download movie. For example, I want to upload movie in internet. So it will take long time in order to upload movie. So in ADSL, there is more download speed when compared to upload speed. Whatever the internet we are using in our house, we call that internet as asymmetric digital subscriber line. And next one is HDSL, that is symmetric digital subscriber line. As whereas in ADSL, there is more download speed when compared to upload speed. But whereas in HDSL, download speed and as well as upload speed, both are equal. Normally, software companies will take HDSL. Guys, for example, if Geo towers are near to our house, then internet will be very fast. And if Geo towers are far away, I will get slow internet. So internet service providers like Jio, Airtel, Active FiberNet, if they are near to our location, internet will be fast or else internet will be slow. Guys, ADSL and as well as HDSL, both are full duplex. Full duplex is nothing but all computers can send data and receive data at the same time. Next, I will explain how ADSL works. ADSL contains two types of devices. They are splitter and ADSL modem. I will explain what is use of these devices. As I already said before, data and voice calls both are traveled by using single cable. So whenever data and voice calls are traveled by using single cable, splitter device will take that voice calls and data and then it will separate voice calls and data. Splitter device contain low pass filter and high pass filter. These filters are electronic components that are present inside splitter device. Low pass filter will take low frequency voice calls and then it will block high frequency data. And similarly, high pass filter will take high frequency data and then it will block low frequency voice calls. So low pass filter will take only voice calls and high pass filter will take only internet data. Because of low pass filter and high pass filter, there will not be any noise in voice calls and data transfer. Whenever high pass filter take internet data, further it will transfer that internet data to ADSL modem. Guys, ADSL modem is a device. It will perform two operations. They are modulation and demodulation. For example, I will send message hello to my friend. It is converted into zeros and ones. So ADSL modem will perform modulation. That is nothing but converting our binary data into analog signals. Analog signals are nothing but continuous waves. So converting our binary data into analog signals is known as modulation. So ADSL modem will perform modulation and it will also perform demodulation. That is nothing but converting analog signals back to binary data. So receiver will read the data. So converting analog signals back to binary data is known as demodulation. ADSL modem will perform these two operations. This is how ADSL will work. So whenever voice calls and data both are travel in single cable, splitter device will take voice calls and data, and in splitter device there is low pass filter and high pass filter. Low pass filter will take only voice calls and it will block internet data, and whereas high pass filter will take only internet data and it will block voice calls. That is why Airtel, Jio, BSNL all are providing internet and voice calls without any interruption. And further, internet data is transferred to ADSL modem, which will perform modulation and demodulation. Converting binary data to analog signals, that is continuous waves, is known as modulation. Converting our analog signals back to binary data is known as demodulation. This is how ADSL works. Next, I will explain what are elementary data link layer protocols. I will explain what are noiseless protocols and noisy protocols. Before starting this video, at first you need to know what is acknowledgement. As for example, there is sender and there is receiver. Sender will send data to receiver. Whenever sender sends data to receiver, receiver will send acknowledgement. Acknowledgement is nothing but reply message. Receiver will give reply whether data is received correctly or not. If sender receives acknowledgement, then sender will understand that data is successfully reached to receiver. So whenever sender don't receive acknowledgement, after sending data, sender will wait some time. If there is no acknowledgement from receiver, sender will again send the same data. So acknowledgement is nothing but reply message. If sender receives acknowledgement, then sender will know that data is successfully reached to receiver And if sender don't receive any acknowledgement, sender will think that data is not reached to receiver, and sender will again send the same data. By using elementary data link layer protocols, two devices can connect to each other and they can transfer data directly. These elementary data link layer protocols will handle errors, and as well as they will handle flow control. Flow control is nothing but how much speed receiver can receive data. Only in that speed, sender will send data. This is meaning of flow control. And this elementary data link layer protocols will do framing. As framing is nothing but packing data. Instead of directly sending data, data is placed in frame and complete frame is transferred to receiver. So elementary data link layer protocol will handle error control, flow control, and as well as framing. Guys, noise mean error. So based on errors in transmission, elementary data link layer protocols are classified into two types. They are noiseless protocols and noisy protocols. At first I will explain what are noiseless protocols. As name itself says. So in noiseless protocols, there will not be any errors. Whenever sender sends data, the data is successfully reached to receiver without any errors. Noiseless protocols are classified into two types. They are simplest protocol and stop and wait protocol. At first I will explain what is simplest protocol. Guys, we also call simplest protocol as unrestricted simplex protocol. Guys, in simplest protocol, whenever sender sends data to receiver, the data is successfully reached to receiver without any errors. And whenever sender sends data frame, receiver will not give any reply. That is, receiver will not send any acknowledgement. So sender can continuously send data and receiver will not give any reply. Yes, frame is nothing but frame is like tracking. Yes, for example, I want to send message how are you. So how is placed in one frame, R is placed in one frame, and U is placed in one frame. And each frame is transferred to receiver. Instead of sending data directly, we will place our data in frame and then we will send that frame to receiver. For example, sender want to send 10 frames. So sender will continuously send all frames without waiting for receiver's response. This is all about simplex protocol. And second one is stop and wait protocol. Guys, in stop and wait protocol, whenever sender sends each frame, receiver will give acknowledgement. Acknowledgement is nothing but reply message. Receiver will send a message like data is reached successfully. This reply is known as acknowledgement. Guys, whenever sender sends one frame, receiver will give reply. Only after receiving reply from receiver, sender will send next frame. This process will continue. Guys, simplex protocol and stop and wait protocol. They are noiseless protocols. There will not be any errors in data transfer. Data will be reached to receiver successfully. Next I will explain what are noisy protocols. Guys, we will use noisy protocols in networks where there will be errors in data transmission. These noisy protocols will handle errors. First noisy protocol is stop and wait ARQ, where ARQ stands for automatic repeat request. Guys, stop and wait protocol and stop and wait ARQ, both are different. In stop and wait protocol, there will not be any errors in data transmission. And whereas in stop and wait ARQ, there will be errors in data transmission. It is similar to stop and wait protocol, but sender will resend frame if error occurs. Whenever receiver receives data with error, receiver will discard that message and receiver will not send any acknowledgement to sender. So after waiting some time, if sender don't receive any acknowledgement, then sender will again send that same data. Guys, for example, at first sender will send data. This data is successfully reached to receiver. So receiver will send acknowledgement. Now sender will send the next data, but receiver will not receive data. So receiver will not send any acknowledgement. Sender will wait some time for acknowledgement. As there is no acknowledgement from receiver, sender will again send the same data. Now data is successfully received to receiver. So receiver will send acknowledgement. This is all about stop and wait ARQ, where ARQ stands for automatic repeat request. Sender will send data. If data is successfully reached to receiver, receiver will send acknowledgement. And if data is not reached to receiver, or if there are any errors in data, receiver will discard that message and receiver will not send any acknowledgement. After waiting some time, if sender don't receive any acknowledgement, then sender will again send that same data. Next I will explain what is go back in ARQ. Guys, whereas if you consider stop and wait ARQ, in stop and wait ARQ, only sender will send one data frame at a time. Only after receiving reply from receiver, sender will send the next frame. But whereas in go back and ARQ, sender can send multiple frames at a time. If any error occurs in any frame, then receiver will discard that frame, and as well as receiver will discard all the following frames from that error occurred frame. I'll give one example. In go back and ARQ, sender can send multiple frames at a time. For example, sender will send 4 frames at a time. Receiver successfully received frame 0. So receiver will send acknowledgement for frame 0. Similarly, receiver successfully received frame 1. So receiver will send acknowledgement for frame 1. Receiver received frame 2, but this frame 2 contains errors. As there are errors, receiver will send negative acknowledgement for frame 2, where NESEK stands for negative acknowledgement. So frame 2 got negative acknowledgement and receiver received frame 3 successfully. Even though frame 3 is received successfully, receiver will discard all the frames from error occurred frame. So receiver will discard frame 2 and as well as frame 3. So now sender will again send frame 2 and as well as frame 3. This is example. Frame 3 got error. So receiver will send negative acknowledgement for frame 3 and as well as all corresponding frames from frame 3. So sender will again send frame 3, 4 and 5. This is all about go back and ARQ. Next I will explain what is selective repeat ARQ. Guys, even in selective repeat ARQ, sender can send multiple frames at a time. But in selective repeat ARQ, sender will not send all the frames. Sender will send only corrupted frame. This is example. Sender will send 4 frames at a time. Receiver got error in frame 2. So receiver will send negative ACK only for frame 2. As only frame 2 got negative ACK, sender will send only frame 2. This is all about selective repeat ARQ. Next I will explain what is piggybacking. Guys, piggybacking method is used in two-way communication. For example, there is sender and there is receiver. In piggybacking method, not only sender will send data, but also receiver will send data. At first, whenever sender send data, receiver will send acknowledgement. Acknowledgement is nothing but reply message. Receiver will send a reply message whether data is received correctly or not. And again after some time, receiver need to send his data. At first sending acknowledgement and then again after waiting some time, receiver sending his data is time taking process. So in order to overcome this problem, in piggybacking, we will not send acknowledgement and data separately. Instead, whenever sender send data at first, receiver will not send acknowledgement immediately. Instead of sending his acknowledgement immediately, receiver will wait until his data is ready. Whenever receiver data is ready, receiver will send acknowledgement for sender data and as well as receiver will add his message. For example, sender will send hello. Whenever sender send hello, receiver will give acknowledgement like message hello is received successfully. Along with acknowledgement, receiver will send his data like hello, how are you? As receiver is sending acknowledgement and as well as receiver data, time will be saved. Instead of sending two separate messages, in piggybacking, both acknowledgement and as well as data is sent at once. As there are only few messages, communication in piggybacking is fast. Piggybacking is a method used in two-way communication to save time and improve performance. Instead of sending acknowledgement separately, receiver waits until it has data to send, and then receiver will attach acknowledgement and as well as receiver data, and then receiver will forward both to sender. As we are sending both acknowledgement and data at once, this will reduce number of messages. This makes communication process fast and more efficient. This is how piggybacking will work. Whenever sender transmits a data frame to receiver, the receiver receives the frame and waits until it has its own data to send. When receiver is ready to send its own data, it includes the acknowledgement for previous sender data in same message. So sender will receive both acknowledgement and as well as receiver data. The same communication process will continue. These are advantages of piggybacking. And the first one is, as we are not sending acknowledgement separately, transmission cost will be reduced. And we are sending both acknowledgement and as well as data at once. So network will consume less space. And communication also will be fast. So in piggybacking, communication process is smooth. These are disadvantages of piggybacking. And the first one is, if the receiver has no data to send, then receiver will delay in sending acknowledgement. Because whenever sender sends data, receiver has no data to send. So receiver will not send acknowledgement. So whenever there is no reply from receiver, sender will think that data is not reached to receiver and sender will again send the data. So piggybacking method is suitable only if both sender and receiver continuously exchange data. Next I will explain what is sliding window protocol, types of sliding window protocols. I will explain what is one-bit sliding window protocol, sliding window protocol using go backend, and sliding window protocol using selective repeat. Sliding window protocol is a method used in computer networks to control flow of the data. Guys, flow control means how much speed receiver can handle data. Only in that speed, sender will send data. Guys, at first you need to know what is frame. Guys, for example, sender want to send data to receiver. Sender will not send data directly to receiver. Instead, sender will place data in frame and then sender will forward complete frame to receiver. Guys, frame is like packing. Instead of sending data directly, sender will pack data in frame and then sender will send that frame to receiver. Guys, for example, receiver can handle only 4 frames at a time. If sender send more than 4 frames at a time, then it will be overload to receiver. That is why sliding window protocol will control flow of the data. So flow control means how many frames receiver can handle at a time. Only that many frames sender will send at a time. Sender must not be very fast in sending the frame. The sliding window protocol is a method used in computer networks to control the flow of data between a sender and a receiver. It ensures that sender does not send data too fast, which could overload the receiver. The sliding window protocol is used in data link layer and as well as transport layer of the OSI model. Conjunction means if sender send data too fast, then receiver may not able to handle it. So sliding window protocol will avoid conjunction. And next one is reduce waiting time. Guys, in sliding window protocol, we need not to send only single frame. In sliding window protocol, we can send multiple frames based on receiver capacity. And third one is improve efficiency. In sliding window protocol, as sender is sending multiple frames at a time to receiver, data transfer is fast. In sliding window protocol, number of frames to be sent is based on window size. Guys, I will explain what is window size with example. Guys, for example, sender want to send 10 frames to receiver. So starting from frame 0 to frame 9. Before sender forwarding frames to receiver, both sender and as well as receiver must decide window size. Window size means how many frames receiver will handle at a time. For example, receiver can handle only 4 frames at a time. So both sender and receiver will decide frame size, that is 4. That means sender can send only 4 frames at a time. At first, sender will send first 4 frames and then sender will wait for acknowledgement from receiver. Only after getting acknowledgement from receiver, sender will send next frame. I'll give example. As window size is 4, at first sender will send first 4 frames 0, 1, 2, 3. So sender will send frame 0, frame 1, frame 2 and frame 3. Only after getting acknowledgement from receiver, sender can send next frame. For example, guys, acknowledgement means reply message. Whenever data is successfully reached to receiver, receiver will send ACK. Like receiver will send data is reached successfully. So receiver will send ACK for frame 0. As sender got ACK for frame 0, now sender will slide window one step forward. That is, sender will move window one step forward in order to send next frame. As frame 0 already got acknowledgement, now window will slide one step forward in order to send next frame. That is frame 4. Now sender will send frame 4. Again after some time, frame 1 is successfully reached to receiver. So receiver will send ACK for frame 1. As sender got ACK for frame 1, again sender will slide window one step forward in order to send next frame. That is, in order to send frame 5. As frame 0 and frame 1 both got acknowledgement, a window will slide one step forward in order to send frame 5. Now sender will send frame 5. This process will continue until all frames are successfully received to receiver. After getting acknowledgement from each frame, we are sliding window one step forward in order to send next frame. That is why we call it as sliding window protocol. This is example. At first sender will send frame 0, 1, 2, 3. After getting ACK for frame 0, sender will send frame 4. Even after getting ACK for frame 1, sender will send frame 5. The sliding window protocols are classified into 3 types. And the first one is One-bit sliding window protocol. Guys, we also call one-bit sliding window protocol as stop and wait ARQ, where ARQ stands for automatic repeat request. Guys, for example, each frame carries 1 bit. So in one-bit sliding window protocol, sender can send only one frame at a time. At first, sender will send first frame, and then sender will wait for acknowledgement from receiver. Only after getting acknowledgement from receiver, sender will send next frame. I will explain one-bit sliding window protocol with example. As we can send only 1 bit, that is, we can send only one frame at a time. That is why we call it as one-bit sliding window protocol. So here window size is only 1. This is example. Sender want to send total 8 frames from 0 to 7, and sender can send only one frame at a time. Only after getting acknowledgement, sender can send next frame. This is sender state. This is receiver state. Initially in sender state, at first sender is not sending any data. So just I am drawing one line. That is nothing but sender is not sending any data. And whereas in receiver state, receiver wants frame 0. At first sender is not sending any data, and whereas receiver is expecting frame 0. Now at first sender will send frame 0. I am representing this diagram with lines. Now sender forwarded frame 0, but still receiver did not receive frame 0. Still receiver is expecting for frame 0. Guys, frame will not reach immediately to receiver. It will take some time to reach. So just now sender forwarded frame. Still that frame is not reached to receiver. Still receiver is expecting frame 0. As frame 0 is already forwarded by sender. Now after some time, receiver will receive frame 0. So total there are 3 stages. First one is sender is not sending any frame, and whereas receiver is expecting for frame 0. This is state 1. And whereas in state 2, sender will forward frame 0, but still receiver will not receive frame 0. And whereas in state 3, sender is already forwarded frame 0, and receiver will get frame 0. Whenever frame 0 is successfully reached to receiver, now receiver wants frame 1. In fourth state, sender is not sending any frame, and whereas receiver is waiting for frame 1. As frame 0 is already received to receiver, now receiver is waiting for frame 1. Again the same process will continue for frame 1. The same process will continue until all frames are successfully reached to receiver. This is all about one-bit sliding window protocol. Guys, we'll use sliding window protocol using go back in and sliding window protocol using selective repeat only when there are errors in data transmission. At first I'll explain what is sliding window protocol using go back in. Go back in is a sliding window protocol used for error control in data transmission. It ensures that data is sent in order and retransmitted if error occurs. As for example, sender wants to send total 8 frames from 0 to 7 and window size is 4. As window size is 4, sender can send 4 frames at a time. So sender will send frame 0, 1, 2, 3. Only after getting ACK from receiver, sender can send next frame. For example, frame 0 got acknowledgement. As sender got ACK for frame 0, a window will move one step forward in order to send next frame, that is frame 4. So now sender will send frame 4. And similarly after some time, receiver will send ACK for frame 1. As sender got ACK for frame 1, the window will move one step forward in order to send frame 5. So now sender will forward frame 5. And whereas for frame 2 is not received to receiver successfully. Frame 2 got errors. So receiver will not send any acknowledgement for frame 2. Frame 2 got error. As frame 2 got error, sender will discard particular error occurred frame and as well as all the remaining frames from error occurred frame. So sender will discard frame 2, frame 3, frame 4, frame 5. As window size is 4, now sender will again send frame 2, frame 3, frame 4 and frame 5. So in sliding window protocol using go back in, whenever any error occurred for particular frame, receiver will discard that particular frame and as well as all the corresponding frames from that particular frame. So sender again need to send that particular frame and as well as all the corresponding frames based on window size. So sender will again send frame 2, 3, 4 and 5. This is all about sliding window protocol using go back in. Next I will explain sliding window protocol using selective repeat. Yes, whereas if you consider go back in go back in, whenever any frame got error, sender will send that particular frame and as well as all the corresponding frames from that particular error occurred frame. But whereas in selective repeat, sender will not send all the frames. Sender will resend only that particular frame which got error. I'll give example. Window size is 3. So sender can send 3 frames at a time. So sender will send frame 0, frame 1 and frame 2, and receiver will send ACK for frame 0. So as sender got ACK for frame 0, now sender will send frame 3, and similarly after some time, receiver will send ACK for frame 1. As sender got ACK for frame 1, now sender will send frame 4. And whereas for frame 2, receiver did not receive frame 2 successfully, frame 2 got error. So receiver will not send ACK for frame 2. As only frame 2 got error, sender will not discard all the frames. Instead, sender will send only particular frame which got error. As only frame 2 got error, now sender will send only frame 2. Now receiver got frame 2 successfully, so receiver will send ACK for frame 2. As sender got ACK for frame 2 successfully, now sender will send frame 5. This is all about selective repeat protocol. Next I will explain what is MAC sublayer protocol, and I will explain various types of MAC protocols. I will explain what are random access protocols, controlled access protocols and channelization protocols. I will explain each and every type in detail. Guys, we also call MAC protocols as multiple access protocols, and MAC stands for medium access control. Guys, in exam you may get separate questions like explain CSMA, explain CSMA CA, what is token passing, what is CDMA, etc. So you need to be perfect on each and every protocol. At first I will explain what is MAC sublayer protocol. Before explaining what is MAC sublayer protocol, at first you need to know what is shared medium or shared communication channel or shared network. For example, there are multiple computers which are connected to a single cable in order to transfer data. As all computers are connected to a single cable, we call this single cable as shared medium or shared communication channel or shared network, because all computers are sharing single cable. Yes, for example, there are multiple devices which are connected to single wireless frequency for communication. As all devices are connected to single wireless frequency for communication, we call this single wireless frequency as shared medium or shared communication channel or shared network. So the shared medium, shared communication channel and shared network, they are nothing but single cable or single wireless frequency. OSI model contains 7 layers, and the second layer is data link layer, and this MAC layer is sublayer of data link layer. And by using MAC sublayer, multiple devices can communicate each other using a shared medium without any interference. Shared medium is nothing but single cable, where all devices are connected to this cable for communication. For example, there are multiple computers connected to a shared network like single cable, and both computers will send data at the same time. If both computers send the data at the same time, then collision will occur. Collision is nothing but interference. Whenever two computers send data at the same time, collision will occur and data will be lost. So this data will be lost and this data will be lost, and both computers will not receive data. So in shared network, whenever multiple computers send data at the same time, collision will occur. So this MAC sublayer will allow only one computer to send data at the same time. MAC sublayer will not allow multiple devices to send data at the same time. So MAC sublayer will allow only single device to send data at the same time. Guys, sometimes collision may occur. Whenever collision occur, computers need to resend data at random time. I will explain what is random time. Yes, for example, this computer will send data at 10 o'clock exactly, and this computer also will send data at 10 o'clock exactly. So as two computers are sending data at the same time, collision will occur and data will be lost. As data is lost, computers need to send data again. For example, these computers will again send data at fixed time, like at exactly 10 o'clock 1 second, this computer will send data, and similarly at 10 o'clock 1 second, this computer will send data. As both computers are sending data again at fixed time, that is 10 o'clock 1 second, again two computers are sending data at the same time, again collision will occur. That is why if collision occurs, computers need to send data at random time, not fixed time. If they send at fixed time, again collision will occur. So random time is nothing but this computer will send data at 10.1 second, this computer will send data at 10.4 seconds. They are sending data at random time, not at fixed time. So collision will not occur. So whenever collision occurs, computers need to send data again at random time. MAC, that is Medium Access Control, is a sublayer of data link layer in the OSI model. It controls how multiple devices share a common communication channel without interference. Communication channel is nothing but single cable. When many devices try to send data at the same time on a shared network, collision can occur. Collision means data interference. So MAC sublayer will ensure that only one device can send data at the same time. So it will avoid collision. When two devices send data at the same time, due to their signal interference, collision will occur. This collision will damage data and receiver cannot receive data due to data loss. Whenever collision occurs, data will be lost. Sender will identify collision and retransmits the data after a short delay. After a short time, again sender will send data. If two computers send data at the same time on a shared network, collision will occur. When collision happens, both computers will stop sending data and they will wait for some random time before trying again. Sending data at random time is done by CSMA CD protocol. And MAC sublayer protocols are classified into three types. Guys, we also call MAC protocols as multiple access protocols. Multiple access protocols are classified into three types. They are random access protocols, controlled access protocols, and channelization protocols. At first, I will explain what are random access protocols. Guys, random access protocols are classified into four types. They are ALOHA, CSMA protocol, CSMA CD protocol, and CSMA CA protocol. At first, I will explain what are random access protocols. Random access protocols in computer networks are methods used to manage how multiple devices share the same communication channel, like a single wire or wireless frequency, to send data. Guys, in random access protocols, multiple devices are connected to single communication channel in order to send data. Guys, in random access protocols, devices can send data at any time, whenever they want. But if two devices send data at the same time, collision will occur. And if collision occurs, devices need to again resend data at random time. Random time in different time. Random access protocols are classified into four types. They are ALOHA, CSMA, CSMA CD, and CSMA CA. I will explain each of them in detail. At first, I will explain what is ALOHA protocol. ALOHA is a random access protocol. In ALOHA protocol, any device can send data at any time. There is no rule that device need to transfer data only at particular time. So any device can send data at any time in ALOHA protocol. Guys, actually ALOHA was used in wireless LANs in order to connect to different places using wireless technology. But this ALOHA is also used in shared medium, where all devices are connected to a single cable. Guys, I already said, in ALOHA protocol, multiple devices can send data at any time. So if multiple devices send data at the same time, collision will occur. If collision occurs, data will be lost. So again, devices need to resend data after waiting for a random time. Guys, for example, there is device 1 and device 2. Both are connected by using a shared medium like a single wire, and both devices are transferring frames at the same time. Guys, frames are nothing but data. Instead of sending our data directly, we will place our data in frame and we will send data. So don't get confused. Frame is nothing but data. We will place our data in frame and we will send that frame. If two devices send frames at the same time, collision will occur. So again, devices need to resend data after a random time. Random is nothing but different time. One device will send data at one time and other device will send data at other time. So random time in different times. Guys, ALOHA protocols are classified into two types. They are pure ALOHA and slotted ALOHA. At first, I will explain what is pure ALOHA. Guys, in pure ALOHA, without following any time period, device can send data at any time, and device will not check whether channel is free or not. Channel is nothing but cable. Device will not check whether cable is free or not. Directly they will send data at any time. And if collision occurs, device need to resend data at different times. That is nothing but random times. As for example, there are 4 devices which are connected to a single cable. These lines are nothing but they are single cable. As I already said before, in pure ALOHA, any device can send data at any time. For example, this is particular time period. In this particular time period, only device 1 is sending data. As no other devices are sending in this time period, receiver will receive this frame. And similarly, this is second time period. If you observe this time period, in this time period, device 1 is sending one frame, device 2 is sending one frame, device 3 and device 4. All are sending various frames. In this particular time slot, as all devices are sending data at the same time, collision will occur and all these frames will be lost. So as all these frames will be lost, receiver will not receive all these frames. In this particular time slot, device 2 is sending one frame and device 4 is sending one frame. As both devices are sending data at the same time, again collision will occur. These two frames will be lost. So again device need to retransmit these frames. In this particular time slot, only one device is sending data in this cable. So this frame is successfully reached to receiver. If collision occurs, all devices need to retransmit all these frames at random time. Random time is nothing but different time. For example, this computer will transfer frame at 10.1 second. This computer will transfer frame at 10.5 seconds and this frame will be transferred at 10.10 seconds and this frame will be transferred at 10 o'clock 12 seconds. Like that, each frame will resend data at random times. This is all about pure ALOHA. Next I will explain what is slotted ALOHA. Guys, if you consider pure ALOHA, in pure ALOHA, any device can send data at any time. So there is high chance for collisions. In order to overcome problem of pure ALOHA, slotted ALOHA was introduced. In pure ALOHA, any device can send data at any time. But whereas in slotted ALOHA, device cannot send data at any time. In slotted ALOHA, data sending time is divided into fixed time slots. As for example, there are three devices which are connected to a single cable. These lines are nothing but all are considered single cable. So this is one single cable. In this single cable, data sending time is divided into fixed time slots. Yes, for example, let's say time is 10 o'clock and here time is 10.5 seconds and similarly here time is 10 o'clock 10 seconds. Like that, sending time is divided into fixed time slots and device can send data only at beginning of time slot. Device cannot send data at middle of time slot. Device need to send data only at beginning of time slot. Yes, for example, device 1 is sending one frame. As no other devices are transferring data in this time slot, frame 1 is successfully reached to receiver. Yes, for example, at 10.2 seconds, this device 2 want to send data, but device 2 cannot send data because in slotted ALOHA, only at beginning of time slot, device need to send data. Then device need to wait for second time slot. Then device need to send data at second time slot, only in the beginning. Yes, for example, if you consider this time slot, in this time slot, both device 1 and device 3, both are sending frames at a time. As both computers are sending frames at a time, collision will occur. So this frame will be lost and this frame will be lost. So again after waiting some random time, again device need to resend data. So even in slotted ALOHA, collision will occur. As for example, if you consider pure ALOHA, for example, let us say time is 10 o'clock. Here second slot begins at 10.5 seconds and here 10.10 seconds. If you observe here, device can send data at any time. They are not following any particular time slot. Like there is no rule that device need to send data only at beginning of time slot. So collision chances are very high. And even in slotted ALOHA, collisions will occur. But when compared to pure ALOHA, collision chances are very less because data will be transferred only at beginning of time slot. If a computer miss allotted time, it must wait for next time slot. This reduces the chances of collision. But if two devices send data at the beginning of the time slot, again collision will occur. So again two devices need to wait for random time and again they need to resend data at next available time slots. This computer will send data at one time slot and similarly this computer will send data at other time slot. Next I will explain what is CSMA protocol. The CSMA stands for Carrier Sense Multiple Access. Name itself says carrier sense. Thus carrier is nothing but single cable. As all devices are connected to single cable, if any device want to send data, at first it will sense carrier. That is, it will check whether any other device is sending data or not. If no device is sending data, then this device will send data. So in carrier sense multiple access, before sending data, at first device will sense carrier. If carrier is free, device will send data. If carrier is busy, device will wait for some random time and it will send data. So before sending data, if device sends carrier, it will reduce collisions. Guys, still in carrier sends multiple axes, collisions will occur. For example, this computer want to send data, so at first it will sense carrier, whether channel is free or not. This computer also want to send data, then this computer also will check whether channel is free or not. If two computers sense channel at the same time, collision will occur. This computer and this computer both will sense channel at the same time and they both will identify that no other device is sending data. And now two computers will send data at the same time in this single channel. As two computers are sending data at the same time, collision will occur. So in carrier sense multiple axis, if two devices sense the channel at the same time, then collision will occur. CSMA is a random access protocol used in computer networks to manage how multiple devices share a single communication channel. In CSMA, multiple devices will share single communication channel. Carrier sense means before sending data, at first device will sense carrier. That is, device will check whether communication channel is free or not. If channel is free, device will send data, and if channel is busy, device will wait for some time and then it will try again. So if device sends channel before sending data, it will reduce collisions. In CSMA protocol, still collisions will occur because of propagation delay. I will explain what is propagation delay. For example, two devices want to send data at the same time. So two devices will check channel at the same time. As two devices are checking channel at the same time, they will identify that channel is free. As channel is free, two devices will send data at the same time. So collision will occur. This is meaning of propagation delay. Guys, CSMA protocols are classified into three types. They are non-persistent CSMA, one-persistent CSMA, and p-persistent CSMA. In non-persistent CSMA, at first device will sense channel and it will identify that in this particular time, some other device is sending data. So channel is busy. So in non-persistent CSMA, at first device will sense a channel and it will identify that channel is busy. So it will wait for some time and again device will sense a channel and still channel is busy. So again device will wait some time and again device will sense a channel. This time channel is not busy. This time channel is free. So as channel is free, this device will send data. Yes, as well in this time period, channel is free. But in non-persistent CSMA, device will wait some time and it will sense channel. That is why time will be wasted. And whereas if you consider one persistent CSMA, in one persistent CSMA, if channel is busy, device will continuously sense channel until channel is free. So here channel is free, device will immediately send data. This is one persistent. In non-persistent, if channel is busy, device will wait some time and then it will sense channel. And whereas in one persistent CSMA, if channel is busy, device will keep on sensing channel continuously. And if channel is free, immediately device will send data. Here time will be wasted. And whereas one persistent CSMA will save time. And next one is p-persistent CSMA, where p stands for probability. Yes, even in p-persistent CSMA, device will continuously keep on sensing channel until channel is free. And if channel is free, device will not send data directly. At first, device will wait some time in order to sense whether any other device want to send data in this time slot or not. If no device want to send data in this time slot, then this device will send data. As for example, in this time slot, probability is less. That means other device want to transfer data in this time slot. So this device will not send data. Similarly, in this time slot, probability is low. That means other device want to use time slot. So this device will not send data. And similarly, here also probability is low. Other device want to use this time slot. So this device will not send data. And at last in this time slot, probability is high. That is, no other device are sending data in this time slot. So this computer will send data in this time slot. This is all about p-persistent CSMA. So CSMA protocols are classified into three types. They are non-persistent, one-persistent, and p-persistent CSMA. In non-persistent CSMA, device will check whether channel is free or not. If channel is busy, device waits for a random time before checking again. If channel is free, device will send data immediately. As device is waiting some time before trying again, it will reduce collisions. Device will not keep on checking continuously whether channel is free or not. So non-persistent CSMA is slow. And whereas in one persistent CSMA, device will keep on checking channel continuously until channel is free. And if channel is free, device will transfer data immediately. So one persistent CSMA is fast. Just for example, this computer want to send data, and similarly this computer want to send data. Other devices are using this channel. So both devices will keep on continuously checking, and immediately when channel is free, immediately both devices will send data. So again collision will occur because after continuously sensing, both devices will send data at the same time. So here collision chances are very high. And whereas in P-persistent CSMA, a device check if channel is free or not. If channel is free, it send data with a probability. If not, it will wait for next time slot and try again. That's where P stands for probability. If probability is less, that means other device may use the channel, so device will not send data. And if probability is high, that means no other device will use this time slot, so this device will send data in this time slot. Next I will explain what is CSMA CD protocol, where CSMA stands for carrier sense multiple access and CD stands for collision detection. Guys, we will use CSMA CD protocol in wide networks like Ethernet cables. In CSMA CD protocol, if any device want to send data in communication channel, at first a device will listen to the channel. Listening is nothing but device will check whether channel is free or not. If channel is free, then device will send data, and if channel is busy, then device will wait some time and again it will send data. And if multiple devices send data at the same time, then collision will occur. In CSMA CD protocol, whenever collision occurs, device will identify collision and device will immediately stop transmission. So in CSMA CD protocol, whenever collision occurs, device will immediately stop transmission. If we stop transmission immediately, then it will save our time. If collision occurs, device will not send data immediately. Instead, before retrying, device will wait for some random time. We call this random time as back of time. After waiting for some random time, device will again send the data. Just for example, this is communication channel, that is nothing but single wire. One device is sending one frame at a time. As device is sending frame, we call it as transmission period. After sending frame, device will not send other frame immediately. It will wait some time before sending other frame. As device is waiting some time in order to check whether collision will occur or not. This time is known as contention period. So contention period is nothing but minimum waiting time that particular device will follow in order to check whether collision will occur or not. This is contention period. As no collision will occur, device will send other frame. Just for example, there are multiple devices which want to send data at the same time. So before sending data, all devices will wait. As all devices are waiting at the same time and they are not sending data, in this particular time period, there will not be any data transfer. We call this time period as ideal period. So as there is ideal period, again device will wait some time in order to check whether collisions will occur or not. We call the time period as contention period. After contention period, device will send data. This is all about CSMA CD protocol. Next I will explain what is CSMA CA protocol, where CSMA stands for carrier sense multiple access and CA stands for collision avoidancy, where in this protocol collision occurrence is very rare, and we will use CSMA CA protocol in wireless networks like Wi-Fi. In CSMA CA protocol, device will listen to the channel before sending data. If channel is free, it will not send data immediately. Instead, device will send one small request to receiver. We call that request as request to send signal. If receiver is ready, then receiver will give one signal. We call that signal as clear to send signal. Once if sender gets CTS signal, then sender will send actual data. As for example, there is sender and there is receiver. Sender will identify that no other device is using this channel, so channel is free. And the sender, before sending actual data, at first the sender will give one signal to receiver in order to send data. We call that signal as RTS signal, where RTS stands for request to send signal. So receiver will take the signal, then receiver will give other signal to sender. We call that signal as clear to send signal. Shortly we call it as CTS. So whenever sender gets CTS signal, Sender will now send actual data. If data is successfully received to receiver, then receiver will give acknowledgement. That is nothing but receiver will give reply like data is reached successfully. Maximum collisions will not occur in CSMA CA protocol. But whenever collision occurs, computers need to wait for some time and again they need to send request to send signals. This is all about CSMA CA protocol. Next I will explain what are controlled access protocols. Guys, controlled access protocols will allow only one device to send data at a time. So it will prevent collisions. And in controlled access protocols, whenever any device wants to send data, at first the device must get permission. Only if device get permission, the device can send data. As device need to get permission before sending data, controlled access protocols will ensure efficient data transfer. That's whereas if you consider random access protocols, in random access protocols, any device can send data at any time without waiting for permission. And whereas in controlled access protocols, device must get permission in order to send data and only one device will send data at a time. So there will not be any collisions. Controlled access protocols are classified into three types. They are reservation protocol, polling protocol, and token passing protocol. At first I will explain what is reservation protocol. Name itself says reservation protocol. If any device wants to send data, at first device must reserve time slot. After device reserving particular time slot, only in the time slot device can send data. Just for example, I want to travel other place in train. So at first what I will do is, I will do one seat reservation. After doing reservation in that particular time period, I can travel in train. Even though if I travel or don't travel, that seat will be reserved. In same way, even in reservation protocol, at first device must reserve a time slot in that particular communication channel in order to transfer data. That this is structure. Just for example, all time slots are empty. For example, this device one reserved this time slot. So in this particular time slot, this device can send data. As already first slot is reserved by device 1, no other device can use this slot. Similarly, now device 2 and device 3, both will reserve slot 3 and slot 4. So in this particular time slots, this device can send data. Guess there will be one central system. The device will give each time slot to each device. These are advantages of reservation protocol. As each device will get particular time slot, there will not be any collisions. Guess reservation protocol is used in satellite communications. And these are disadvantages. And the first one is, just for example, device 1 took this time slot, but device 1 is not sending data. So this time slot will be wasted. And in order to give reservations for each device, there must be one central system. So if central system fails, device will not get time slots and device cannot communicate. This is all about reservation protocol. Next I will explain what is polling protocol. As for example, if you want to vote, we will go to polling booth. In polling booth, there will be one employee. He will call each person in order to vote. Even in polling protocol, there will be one central device. This central device will call to each device in order to send data. Once if device 1 send data, the system will call to device 2. Again device 2 will send data. So central computer will call each device in circular manner. If device don't want to send data, then the central system will call to other device. These are advantages of polling protocol. A server will call each device one by one. There will not be any collisions. And next advantage is server will give chance for each device in order to send data. And these are disadvantages. A server calling each device one by one. So polling protocol is slow. And if central system fails, device cannot send data. And third one is token passing protocol. First device will get one token. So whenever device get token, this device can send data to other device. After this device successfully sending data, this token is given to device 2. Device 2 will send data. Similarly, token is given to device 3, device 4 and so on. So token is passed in circular manner. Whenever device get token, at that time device can send data. If device don't want to send data, then token is moved to other device. These are advantages. As only one device can send data by using token, collisions will not occur. Guys, token passing protocol is suitable for computers which are connected in circular manner. Once if any device lost token, communication stops until new token is generated. So device need to wait long time in order to get new token. Next I will explain what are channelization protocols. Guys, we will use channelization protocols mainly in wireless communications. In channelization protocols, we will divide our entire communication channel into smaller channels. After dividing entire channel into separate smaller channels, will give each separate channel to each user. So by using the smaller channels, users can communicate. As each and every user will get separate channels, all users can send data at the same time. So there will not be any interference. Guys, bandwidth is nothing but how much amount of data that can be traveled per second in communication channel. So in channelization protocols, all users can send data at the same time. So lot of data will be traveled in network at the same time. So there will not be any bandwidth wastage. Even though multiple users send data at the same time, collision will not occur. The channelization protocols will use multiplexing. Multiplexing means in single communication channel, as each user will get one separate small channel, multiple users can send multiple signals at the same time. This is meaning of multiplexing. The channelization protocols are classified into three types. And the first one is frequency division multiple access. Name itself says frequency division. That is nothing but entire frequency is divided into smaller frequencies and each user will get one frequency. By using that small frequency, users can communicate. As for example, there is one big wireless frequency band. For example, this frequency will support data speed that is 1000 GB per second. But if you assign this entire frequency to single user, a single user don't get this much frequency. So entire frequency will be wasted. So in frequency division multiple access, our entire communication channel is divided into smaller channels and each channel will get one small frequency. By using that small frequency, device can communicate. So in frequency division multiple access, we will divide our transmission medium into smaller frequency bands and each user will get one frequency band. By using that frequency band, users can communicate. As each user will get one frequency band, all users can communicate at the same time. So even though all users send data at the same time, there will not be any interference. Collision will not occur. As for example, this is communication channel. We will divide our communication channel into smaller channels and each user will get one channel. By using that channel, user can communicate. As for each and every channel, we need to leave small gap. If we leave small gap, two channels will not interfere. That is why we need to give small gap between each and every channel. We call this gap as guard band. As for example, this is entire frequency that communication channel will support. This entire frequency is divided into smaller channels. Each user will get one frequency. As each device will get one frequency, by using that frequency, device can communicate. These are characteristics of frequency division multiple access. And the first one is frequency allocation. As I already said before, each user will get one frequency band. By using that band, users can communicate. And second one is continuous transmission. That's all devices can transfer data at the same time. So there is no need of waiting for time slot. All users can send data at any time. So there will be continuous data transfer. And third one is guard band. For each and every channel, we need to leave small gap. We call that small gap as guard band. If we leave small gap, channels will not interfere. All channels can communicate smoothly. And these are applications. We used FDMA in 1G mobile communications. And we also used FDMA in FM radio stations. These are advantages. First one is simplicity. FDMA is easy to implement. And next one is low latency. As each user has separate frequency band, data can be transferred without waiting for time slot. So there will not be any latent data transfer. These are disadvantages. And the first one is, as each user get one separate frequency, if user don't use that frequency band, then that frequency band is wasted. If users increases, then managing frequency bands are very tough. Next I will explain what is time division multiple access. Name itself says time division. Instead of dividing entire frequency, here we will divide our entire communication channel into time slots. And each user will get one time slot. And that particular time slot, user can communicate. These are characteristics of TDMA. And the first one is time slot allocation. I already said before, each device will get one time slot. And that particular time slot, device can communicate. And second one is synchronization. Yes, synchronization means each device must know at what time slot will begin and at what time slot ends. So device can use only that particular time slot or else collision will occur. These are applications of TDMA. We will use TDMA in 2G networks and also in satellite communications. This is structure of TDMA. We will divide our entire frequency into time slots. So each user will get one time slot. On that particular time slot, user can communicate. These are advantages of TDMA. And the first one is efficient bandwidth usage. As each and every user will get one time slot, all users will use time slots without wasting. And also, multiple users can send data at different time slots without interference. As channel is divided into time slots, there will not be any interference. As device will use only particular time period in order to send data, power charges will be low. These are disadvantages. And the first one is communication delays. As user need to wait for time slot for communication, so there will be communication delay. Because for each and every time slot, we will leave some time in order to avoid collision, and we call the time as guard time. So some time will be wasted for communication. And next disadvantage is each and every user must follow particular time slot. If they don't follow particular time slot, collision will occur. And last one is code division multiple access. Name itself says code division. Guys, in code division multiple access, all devices will send data at the same time. Even though all devices send data at the same time, there will not be any collision, because along with data, each user will add separate code. Based on this code, data will be transferred to correct receiver. So in CDMA, one channel carries all transmissions simultaneously. Simultaneously means all devices can send data at the same time. This is all about CDMA, that is code division multiple access. Next I will explain what are collision free protocols. Yes, for example, there are multiple computers which are connected to single cable. We call this single cable as shared medium. So all computers are connected to single cable for communication. In shared medium, whenever multiple computers send data at the same time, collision will occur. For example, this computer want to send data to this computer, and similarly, this computer also want to send data to this computer. For example, exactly at 10 o'clock, both computers will send data to this computer. Whenever two computers send data at the same time, collision will occur. So both computers' data will interfere each other. So collision will occur. Collision is nothing but interference. Whenever two computers send data at the same time, collision will occur. And whenever collision occurs, data will be lost. So this computer will not receive data of these two computers. So in shared medium, whenever multiple computers send data at the same time, collision will occur. So if multiple computers want to send data without any collision, then they need to use collision-free protocols. So collision-free protocols are network communication methods that prevent data collisions when multiple devices try to send data at the same time. This protocol ensures smooth data transmission without loss or corruption. So by using these protocols, multiple computers can communicate each other in shared network. Yes, collision-free protocols are classified into three types. And the first one is bitmap protocol. Yes, in shared network, whenever multiple computers send data at the same time, collision will occur. So in order to overcome this problem, so bitmap protocol will give particular time slot to each and every device. So only in that particular time slot, device can communicate. For example, this computer is given time slot, that is 10 o'clock, and similarly, this computer is given time slot, that is 10:05 seconds, and similarly for this computer 10:10 seconds, similarly for this computer 10:15 seconds. So only in this particular time slot, device can send data. As each and every computer has different time slots, all computers will send data at different times. So collision will not occur. Yes, for example, there are 4 devices in network. So device 1 is in first position. So first time slot is given to device 1. And similarly, second time slot is given to device 2. And third time slot to device 3. And fourth time slot to device 4. So channel is nothing but single cable. Through single cable, each device can send data at particular time slots. Yes, for example, device 1 and device 4. Both computers want to send data in the time slot. If device 1 and device 4 want to send data in the time slots, before sending data, at first device 1 and device 4, both computers need to send one control message. That is nothing but both computers will send bit 1. So this computer will send bit 1 and this computer will send bit 1 in order to reserve this channel. As two computers want to send data, both will reserve the time slots. And device 2 and device 3, both devices don't want to send data in the time slot, so they will not reserve the time slot. As both computers sent a control message, now they can send data. This is all about bitmap protocol. So in bitmap protocol, each and every device in network gets a fixed time slot based on their positions. Before sending data, a control message, that is nothing but bit 1 is sent in order to reserve channel. After reserving channel, each and every device will send data one by one in their particular time slots. Yes, normally we will use bitmap protocol in wide local area networks if devices want to send data one by one in order. And next protocol is binary countdown protocol. As name itself says, binary countdown. Here, each and every device is given one unique binary number. We also call this unique binary number as priority number. I'll give one example. Just for example, there are 3 computers in network. All these computers want to send data at the same time. Binary countdown protocol will give unique binary numbers to each and every device. Binary countdown protocol will allow only one single computer with the highest binary number to send data. As for example, for this computer, binary number is 101, that is 5. And similarly, for this computer, binary number is 110, that is 6. And similarly, for this computer, binary number is 011, which is 3. These 3 computers want to send data at the same time. System B has highest priority number. So only system B will send data at first. So as only one device will send data at particular time, collision will not occur. So in binary countdown protocol, each and every device is given unique binary number. We call it as priority number. If all devices want to send data at the same time, then only device with the highest priority wins and the device will send data. After device with the highest priority send data, again the same process will repeat for remaining devices. This is all about binary countdown protocol. And third one is token passing protocol. In shared communication channel, first device is given one token. As this computer got token, at first this computer will send data. After this computer sending data, token is passed to device 2. Again device 2 will send data. After device 2 sending data, token is passed to device 3 and to device 4 and so on. So token is passed to each and every device in circular manner. As only one computer with token can send data, collision will not occur. And last one is polling protocol. Guys, in polling protocol, there is one central system. This system will call to each and every device line by line in order to send data. At first, this computer will call to system 1 in order to send data. After system 1, this computer will call to system 2 and then system 3, system 4 and so on. These are 4 collision-free protocols. Next, I will explain what is Bluetooth. Guys, as we know, Bluetooth is wireless communication technology. By using Bluetooth, we can transfer files from one device to other device. So Bluetooth is a wireless communication technology used for shorter range data exchange between devices. Guys, if one device transfer data to other device by using Bluetooth, data is transferred in the form of radio waves with frequency range that is 2.4 GHz. Guys, Bluetooth will follow standard that is IEEE 802.15.1 standard, where IEEE stands for Institute of Electrical and Electronics Engineers. Guys, this is one of the institute that will create rules. Rules are nothing but standards. As Bluetooth will follow this rule, that is why wireless communication will be happen between devices. These are features of Bluetooth. And the first one is shorter range communication. Guys, by using Bluetooth, devices can communicate each other, that is up to 10 meters away. As Bluetooth will consume less power consumption, so Bluetooth is suitable for mobile devices. And by using Bluetooth, we can connect to multiple devices at the same time. Guys, Bluetooth frequency range is not fixed. Bluetooth will change frequency many times in order to avoid interference. These are applications of Bluetooth, and the first one is wireless accessories. Guys, by using Bluetooth, we can connect to headphones, we can connect to wireless speakers, and also we can connect to wireless keyboard, etc. And by using Bluetooth, we can transfer files from one device to other device. Guys, we also use Bluetooth in smart home devices. For example, by using Bluetooth, we can control lights, we can also control locks, etc. Guys, we also use Bluetooth in healthcare devices. For example, Bluetooth is used in wireless heart rate monitor. Next, I will explain what is Zigbee. Guys, same like Bluetooth, Zigbee is also a wireless communication technology. Zigbee is a low-power wireless communication technology designed for IoTs and also for automation systems. We'll use Zigbee technology in IoT. For example, if you consider smart lights, smart watches, smart doors, all these devices will work based on Zigbee technology. And automation systems are nothing but, for example, if you consider smart lights, when we enter, automatically lights will turn on. And whenever we leave our house, automatically lights will turn off. Because smart lights contain sensors, and whereas sensors will work based on Zigbee technology. So we will use Zigbee technology in IoTs and as well as automation systems. And whereas Zigbee will follow standard, that is IEEE 802.15.4. That standards are nothing but rules. Based on the standards, the Zigbee technology will work. Whereas if you consider Bluetooth, Bluetooth is used only for shorter range communication, that is only 10 meters away. And whereas if you consider Zigbee, Zigbee is used in longer range communications, that is up to 100 meters away. Zigbee device will work many years because they will consume less power. and we will use Zigbee technology in automation and as well as sensor based systems. These are applications of Zigbee, and the first one is smart homes. Yes, if you consider smart bulbs and security alarms, this device contains sensors, and the sensors will work based on Zigbee technology. And also we'll use Zigbee in industrial automation in order to make machines work automatically, and we will also use Zigbee in healthcare monitoring, where medical device contains sensors, and that sensors will work based on Zigbee technology. Guys, we will also use Zigbee technology in agriculture monitoring in order to measure temperature, soil moisture, etc. All these are applications of Zigbee. Next, I will explain what is bridge and various types of bridges. Guys, bridge is a device. By using bridge, we can connect to multiple local area networks. For example, there is college. College contains two buildings side by side. So this building 1 is considered as one local area network and building 2 is considered as one local area network. I will connect to these two buildings by using bridge device. Guys, if we connect to these two buildings directly without bridge, then these two buildings is considered as only single network. As both buildings are connected directly, many devices will communicate each other in network, so traffic will be very high. If traffic is high, the network performance decreases. That is why we need bridge. Bridge will divide our network into two segments. Bridge will handle traffic and performance increases. Guys, bridges are classified into three types. And the first one is transparent bridge. We also call this transparent bridge as learning bridge. Computers don't know that bridge is connected to this network. That is why we call this bridge as transparent bridge. Yes, for example, there are three LANs, where LAN stands for local area network. As three LANs are connected by using transparent bridge, this transparent bridge will maintain MAC addresses of each and every device. This transparent bridge will store each and every device MAC address in table. Thus, for example, this computer wants to send data to this computer. So whenever this computer sends data, transparent bridge will identify this device by using MAC address. As all MAC addresses are present in this table, transparent bridge will send data to this computer based on MAC address. For example, this computer wants to send data to this computer, but this computer MAC address is not present in this table. So whenever MAC address is not available in this table, then this transparent bridge will send data to all segments connected to network. So data is transferred to each and every segment. Thus, we also call transparent bridge as learning bridge, because this bridge will learn a MAC address. Learning MAC address is nothing but this bridge will store MAC address of each and every device connected to this network in table. So learning is nothing but storing MAC addresses in table. And based on this MAC address, bridge will identify devices and then it will send data. Guys, we'll use transparent bridge only in Ethernet networks, where all devices are connected by using Ethernet cables. And second one is spanning tree bridge. As for example, there are two LANs. This computer wants to send data to this computer. These local area networks are connected by using two bridges. So whenever this computer sends data, these both bridges will take data. This bridge 1 will send data to bridge 2, and similarly, bridge 2 will send data to bridge 1. And data keeps on circulating between these two bridges. As data keeps on circulating, data will not reach to receiver and data will keeps on repeating, which is slow down or crash the network. So in order to overcome this problem, spanning tree bridge will use spanning tree protocol, where spanning tree protocol will choose only one single route in order to transfer data. As for example, there are two routes. Spanning tree protocol will identify that this route is very short. So spanning tree protocol will choose only this route and then it will block all remaining routes. So data can be transferred only by using single route. As data can be transferred by using only single bridge, data will be reached to receiver successfully. So spanning tree bridge prevents loop in a network when multiple bridges are used. It uses spanning tree protocol to create loop-free network. It finds the best path for data transfer. So spanning tree protocol blocks unnecessary paths and then it will choose only one best path in order to send data. As spanning tree protocol will choose only one short and best path, data will be transferred to receiver very fast. And last one is source routing bridge. Name itself says source routing. So bridge will not find best route. Source computer will find best path in order to send data. Here bridge will not take decisions. Just a bridge will follow route given by the sender and then bridge will send data. So in source routing bridge will not maintain MAC addresses of devices. This is all about source routing bridge. Next I will explain operations of simple two-port bridge. Guys, port is nothing but connection point. Just for example, there are two local area networks and these two LANs are connected to bridge by using two ports. Ports are nothing but connection point. Bridge contains two pins, and by using these pins, two local area networks are connected. So we call this connection point as port 1, and similarly this connection point as port 2. As this bridge contains two ports, we call this bridge as two-port bridge. As for example, in LAN 1, computer D want to send data to computer E. So whenever computer D want to send data to computer E, at first data is transferred to bridge, and bridge will identify that both computers belongs to same LAN. As both computers are in same LAN, this device can communicate directly without bridge. So whenever device D send data, bridge will block the data. If device want to communicate on same LAN, bridge will block the data. For example, device A is in LAN 1 and device X is in LAN 2. Device A want to send data to device X. As both belongs to different LANs, now bridge will allow communication. So bridge will take data from device A and then bridge will send data to device X. This is all about two-port bridge. These are operations of two-port bridge. And the first one is learning MAC address. I already said before, bridge will store MAC address of each and every device. If receiver MAC address is within LAN, bridge will not send data and bridge will block the data. This is known as filtering traffic. And if receiver MAC address belongs to different segment, then bridge will forward the data. This is known as forwarding data. And last one is avoiding loops. Guys, if there are multiple bridges used in networks, then that bridges will follow spanning tree protocol. Whereas in spanning tree protocol, device will choose only one best route and it will block all remaining routes. As device will choose only one best route, data will be transferred to receiver very fast. There will not be any loop. These are operations of two-port bridge. Next I will explain what are wireless local area networks. Shortly we call it as wireless LANs, or you can also call it as WLAN. Guys, for example, there is college building. This college building is considered as one local area network. In this college building, there are so many floors and each floor contains so many devices like laptops, tablets, smartphones, etc. All the devices in college building are connected to college Wi-Fi wirelessly and all devices will communicate each other. As all devices in college building are connected to college Wi-Fi wirelessly, we call it as wireless local area network. And whenever one device sends data to other device wirelessly, data will be transferred in the form of radio waves. So a wireless local area network is a network that connects devices without using wires. Instead of cables, it uses radio waves to send and receive data. It allows devices like laptops, smartphones and tablets to communicate wirelessly within a limited area, such as home, office or school. As for example, in school, by using router, all devices will connect to Wi-Fi network and they will communicate each other. For example, in my house, I will connect my mobile, iPad and laptop to home Wi-Fi. As all devices are connected to Wi-Fi network wirelessly, this is another example of wireless LAN. Next I will explain features of WLAN. And the first one is no physical cables. Guys, in wireless LANs, devices can communicate wirelessly. Whenever one device sends data to other device wirelessly, then data will be transferred in the form of radio waves. So there is no need of any physical cables. And second one is portable. As all devices are not connected by using cables, we can easily move our devices. Still devices are connected to network. And third one is scalable. In wireless local area networks, we can easily add new devices to our network. For example, simply I will connect my new mobile to Wi-Fi and I will use. And next feature is IEEE 802.11 standards. Standards are nothing but rules, as all devices are communicating wirelessly because of this standard. Next I will explain types of WLANs. And the first one is infrastructure mode WLAN. As for example, if you consider internet in houses, all devices are connected to router wirelessly in order to access internet. And whereas this router is connected to internet, guys, inside router, there will be access point. Access point is nothing but, it is like hardware part. So access point is the point where devices are connected to network wirelessly. So in infrastructure mode, devices will not communicate to each other directly. Instead, devices are connected to access point in order to access network. And second one is ad hoc mode. Guys, in ad hoc mode, there will not be any access point like router. Devices will communicate to each other directly without any access point. And last one is mesh wireless LAN. Guys, in mesh WLAN, there will not be single access point. There will be multiple access points. As there are multiple access points, it will extend network coverage. So it will cover large area. These are three types of WLANs. Next I will explain components of WLANs. And the first one is wireless access point. Access points are present in devices like routers and switches. All devices are connected to network by using this access point. And second component is wireless network interface card. By using this hardware part, we can connect to network directly. We call that hardware part as wireless NIC. For example, if you consider laptops, by using laptop, we can connect to network wirelessly. It is happened because of NIC card. And third one is router. So router is a device. By using router, we can connect to network wirelessly. And fourth one is clients. Any device that are connected to wireless networks is known as clients. Devices like laptops, smartphones and tablets that are connected to wireless network. So these devices are examples of clients. This is all about wireless local area network. Next I will explain what is IEEE 802.11 standard. Guys, IEEE stands for Institute of Electrical and Electronics Engineers. This institute will create standards. Standards are nothing but rules. So IEEE created 802.11 standard, that is nothing but rules. By using this standard, devices can communicate each other in wireless networks. Yes, for example, if you consider devices like laptops, smartphones and tablets, all these devices will work by using Wi-Fi based on the standard. As Wi-Fi will work based on standard, IEEE 802.11 standard. So IEEE 802.11 is the standard for wireless LANs, mainly for Wi-Fi, which allow devices like laptops, smartphones and tablets to connect to network without cables. Devices can communicate each other wirelessly without cables. This IEEE 802.11 standard contains two types of architectures. And the first one is infrastructure mode and second one is ad hoc mode. At first I will explain what is infrastructure mode. By using infrastructure mode, devices can connect to internet by using access point. This mode uses a central access point to connect to devices. Devices communicate through access point, not directly with each other. Used in homes and offices. Guys, for example, if you consider your home Wi-Fi, as routers contain access point, by using that access point, devices can connect to internet. This is architecture of infrastructure mode. Yes, for example, there are various kinds of devices like laptops, computers, tablets, mobiles, etc. And there is internet. Now I want to connect my device to internet. So we can connect a device to internet by using router. For example, my router contains two access points. One is access point 1 and next one is access point 2. So devices like routers contain access point. By using that access point, we can connect our device to internet. Guys, devices that are connected to network is known as stations. So stations are nothing but devices. These are components of infrastructure mode. And the first one is AP. Guys, AP stands for access point. It is the point where devices are connected to network, like internet. And stations are nothing but devices that are connected to network. Guys, BSS stands for Basic Service Set. Router contains two access points. For example, if you consider this mobile and tablet, these two devices are connected to single access point, that is access point 2. So devices that are connected to single access point is known as BWS. And next one is EWS, where EWS stands for Extended Service Set. Network that contains multiple access points. We call that network as EWS. Where this network contains multiple access points. So this network will cover large area. And last one is DS, where DS stands for Distribution Systems. If we establish connection between two access points by using cable, then we call that network as distribution system. This is all about infrastructure based architecture of IEEE 802.11 standard. Next architecture is ad hoc mode architecture. As in this architecture, devices will communicate each other directly. There will not be any access point. For example, there is station 1, 2, 3. Stations are nothing but devices that are connected to network. All these devices will communicate each other directly without any access point. Next I will explain services provided by IEEE 802.11 standard. Where this standard will provide two types of services. And the first one is station services and second one is distribution services. Stations are nothing but devices like laptops and mobiles. This standard will provide various kinds of services to devices. And the first one is authentication service. Yes, authentication means verifying device. Yes, for example, by using my mobile, I want to connect to Wi-Fi. So what I will do is I will enter password. If my password is correct, then authentication is successful. I can access internet. If my password is wrong, then my device will be disconnected from network. This is known as deauthentication. And third service is privacy. Because whenever we transfer data in network, my data is converted into unreadable format. Even though if a hacker hacks our data, he cannot read our data because data is in unreadable format. And last service is data delivery service. By using this standard, sender can correctly send data to receiver in wireless network. These are for station services. And second one is distribution services, where these services are used for managing Wi-Fi network. And the first one is association. If we connect our device to access point, then we call it as association. Whereas if we move our device from one access point to other access point, then we call it as reassociation. And whenever we take our device far away from network, then our Wi-Fi will be disconnected. We call it as disassociation. If we transfer our data from one access point to other access point, then it is known as distribution. And next one is integration. If we connect our Wi-Fi to any wide network, then we consider it as integration. These are various distribution services. Next I will explain frame format of IEEE 802.11 standard. That's for example, I want to send message hello to my friend. So whenever I send hello to my friend, my data is not transferred directly. Instead, my data is placed in frame and this complete frame is transferred to receiver. This frame is like packing. Instead of sending our data directly, we will pack our data in frame and then we will send our entire frame to receiver. Whatever the data we place in frame, we call the data as payload. So payload is nothing but actual data being transmitted. Along with our actual data, we will include so many things in frame. And the first one is frame control. Guys, frame control size is 2 bytes. That is nothing but 16 bits. So by using frame control, network will identify that what kind of data that is present inside the frame. So frame control helps in identifying what kind of data is being sent. And second field is duration. How much time particular device will use communication channel in order to transfer data. The time is included in duration field. So by seeing duration field, device will understand that how long particular device will use communication channel. In that time, other device will not use that channel. So collisions will not occur. Duration field is also 2 bytes. And next field is address field. Guys, if you want to identify any person, we can identify person by using Aadhaar number. In same way, if you want to identify any device in network, we can identify device by using MAC address. Address field is 6 bytes. So address field contains sender MAC address, receiver MAC address, and as well as access point MAC address. Based on these addresses, device can communicate in network. Sender MAC address 2 bytes, receiver MAC address 2 bytes, and access point MAC address 2 bytes. Total 6 bytes. And next field is sequence control. Guys, by using sequence control, we can send our data in sequence manner. And sequence control can identify duplicate values. Actual data which we are sending is known as payload. For example, I am sending message hello. So message hello is considered as payload. And last field in frame is frame check sequence. We also call it as checksum. This field is 4 bytes. By using this field, we can identify errors in our data. Next I will explain what is static channel allocation and dynamic channel allocation. That channel is nothing but cable. For example, our computers will communicate to each other in network by using single cable. So we call this single cable as channel. Guys, before explaining what is static and dynamic channel allocation, at first you need to know what is bandwidth. Maximum amount of data that can be transmitted in a network in a given time is known as bandwidth. For example, this network will support 1000 Mbps. That means 1000 MB of data can be transmitted per second in this channel. So 1000 MB per second is known as bandwidth. At first I will explain what is static channel allocation. In static channel allocation, total bandwidth is divided into fixed channels and each user will get one channel for communication. For example, entire channel bandwidth is 1000 MB per second. So each user will get 100 MB per second bandwidth. In this bandwidth, users can communicate in network. Even though if users use or don't use that bandwidth is available to users. FDMA and TDMA both are examples of static channel allocation. For example, if you consider FDMA, where FDMA stands for frequency division multiple axis, name itself says frequency division. So entire frequency is divided into smaller frequencies and each user will get one small frequency. In that small frequency, users can communicate. And whereas TDMA stands for time division multiple axis. Name itself says time division. Entire time in network is divided into smaller time slots, and each user is given one time slot. In that particular time slot, device can communicate. Thus, in static channel allocation, we will pre-assign fixed bandwidth to each user. If user use that bandwidth, then there is no problem. But if user don't use that bandwidth, then this bandwidth is wasted. So static channel allocation is suitable only for smaller networks. If you are using larger networks, then giving fixed bandwidth to each and every device is very tough. So if you are using larger network with many devices, then you can use dynamic channel allocation. In dynamic channel allocation, channels are not pre-assigned. They are given only whenever user need them. For example, this user want to send data. Only at that time, this user is given bandwidth. As we are not pre-assigning fixed channels, device will send data only whenever they need. So bandwidth will not be wasted. Dynamic channel allocation is used by CSMA CA protocol, where CSMA stands for carrier sense multiple axis and CA stands for collision avoidance. This protocol will use dynamic channel allocation. If you consider present 4G and 5G networks, these networks are using dynamic channel allocation. So dynamic channel allocation is suitable for larger networks like mobile networks, internet and motor and wireless communications. Next I will explain difference between static channel allocation and dynamic channel allocation. In static channel allocation, channels are fixed and pre-assigned to users. It is suitable for smaller networks. And whereas in dynamic channel allocation, channels are not pre-assigned. Channels are given to users only whenever they need. It is suitable for larger networks. In static channel allocation, as we are giving fixed channel to each user, if user don't use a channel, then bandwidth will be wasted. So resources are wasted if they are unused. In dynamic channel allocation, only whenever device want to communicate, only at that time we will give bandwidth. So there will not be any resource wastage. Collisions will not occur in static channel allocation. And whereas in dynamic channel allocation, collisions will occur, and these collisions can be handled by using various protocols. Static channel allocation is used in FDMA and TDMA protocols, and whereas dynamic channel allocation is used in 4G, 5G, Wi-Fi and internet. Next I will explain difference between flow control and error control. Yes, flow control means how much speed receiver can take data, only in that speed sender will send data. This is meaning of flow control. And error control means whenever sender send data to receiver, if receiver got any errors in data, then detecting and as well as correcting that errors is known as error control. In flow control, as sender will send data based on receiver capacity, so there will not be any data loss. And whereas by using error control, data will be successfully transferred to receiver without any errors. Flow control stops the data overflow by slowing down the sender. Data will be successfully transferred to receiver without any errors. So error control prevents corruption and loss of the data. Flow control will use methods like stop and wait protocol and sliding window protocol. And whereas error control will use methods like stop and wait ARQ, sliding window ARQ, go back in ARQ, and selective repeat ARQ, where ARQ stands for automatic repeat request. Guys, I already explained all these methods in detail. Next I will explain similarities between flow control and error control. Both flow control and as well as error control will ensure reliable communication. Reliable communication means data will be successfully transferred to receiver without any errors, and communication between sender and receiver will be smooth. And second one is use acknowledgement. Guys, acknowledgement means reply message. Whenever sender send data to receiver, receiver will give reply. If the data is received successfully or not, we call that reply message as acknowledgement. And third one is prevent data loss. Guys, if sender send data too fast, then receiver cannot handle the data, so there will be overflow of the data. So flow control will prevent overflow. And whereas by using error control, data can be successfully transferred to receiver without any loss or corruption. We will use flow control and error control in data link layer and as well as in transport layer of the OSI model. These are similarities between flow control and error control. So I will explain what is data link layer switching. For example, let us say there is college building. This college building is considered as local area network. So in college building, in each and every floor, there are multiple computers, and all these computers are connected By using switch, whenever one computer wants to send data to other computer in local area network by using switch, guys, each and every computer contains MAC address. By using that MAC addresses, devices can communicate each other. So if all devices are connected by using switch, then devices will communicate each other by using MAC address. Instead of IP address, devices are using MAC address. So data transfer is very fast. This is all about data link layer switching.